All right. Parts have been trickling in. I ordered shoulder bolts. I don't know where the shoulder bolts are. Eventually they'll get here so we can work on burning the subs a little bit. I'm in a holding pattern a little bit here. Where am I? What is this place? What's going on here? Wasn't as much of a drop as I'd hoped it'd be. All right, let's see here. Right. Man, nobody's around. Welcome, welcome, welcome. Another day of this, huh? Another day in paradise. Let's see if we can't get the high side, well, I guess in low side too, MOSFET drivers to drive our FETs. See if that'll get the motor to actually work properly. My only concern is with the voltage here. And that's our voltage range. $16 volts from a 9 volt. Well, we're not going to give it 9 volts. I mean, I guess we could do 2S with this if we really wanted to. It's always nice to be able to scale. Although you blow up the microcontroller. I need like a Zener diode or something in there. Then it would just bleed all the excess. It'd be good. There's my application right there. Hey, not a bag of Milky Ways. How you doing? Not a bag of Milky Ways. Someone with Prime for 10 months. 10 months of Prime. Let's put you up on the board. Thank you for subbing. Saying burn with the funk emotes. That's right. That's right. Put you up. Oh yeah, I gotta turn the board on. I mean, it's running. I just have to activate it. Activated. I'm gonna crack open the window. It's gonna be freezing down here today. Oh, there it goes. It's trying to place not a bag of Milky Ways. Or if not a bag of Milky Ways is gonna finally break the board. Uh-oh. Uh-oh. It's taking a long time to find a spot. First name of the day? Is it gonna really... We're gonna catch up on this one? Wow. That's not even a long name. I didn't think we were on the brink. This is... Ooh, this is a long time. This is unprecedented, actually. Uh-oh. Uh-oh. Oh, man. Am I gonna add to this woodworking? Are you gonna have to do woodworking this week? Are we gonna have to do... We're gonna have to do woodworking this week? Are we gonna have to do woodworking this week? Did not a bag of Milky Ways break the board? Oh no. That's gonna go for a while. Oh, there it goes. Wow, that was like a minute. The beginning of the end, my friends. Beginning of the end of this board. Keep in mind it is random, so I mean, statistical probabilities being what they are, the fact that it hasn't been taking a little while to place all the names is kind of also kind of ridiculous. Because I mean, if you look, there's plenty of spots. We're just relying on randomness. I don't have Ligma or Sugma, sorry. We don't have that here, tradesplatter. Not a bag, you're going by Brachus Rect. I mean, there's, like, you could see plenty of spots in the immediate area right here where it would fit. Well, welcome to the board. Thank you so much for the 10 months. The name is too powerful. It is a little bit long. I don't know. Tradesplatter's probably already placed. Yeah, Tradesplatter's already found a spot. Did my music run out? No, it's just very quiet. Thank you for subbing, Tradesplatter. That would be 12 months. Oh man, good amount of time. Yeah, I can see the music. There's like barely like rumbling going on in the song. It's just a FTL soundtrack. What's up, Captain Neo Lime? Tradesplatter, you're going by, hold on, I'm gonna cough. Going by Robot's Facts and a bunch of other good names that I'm not gonna read because I'm gonna start coughing again. Welcome to the board. I guess I left the thermal imager plugged in over the weekend. It's okay. My fingers are cold. Look at that. Cold fingers. Eerie action music. I want to vet this out. If this works, then I need to get to designing because I'll have more parts that need to go down here. Need to get rid of the diodes, I guess, and possibly get rid of the diodes. Do we still have diodes on this thing? Did I leave them installed? I took them out, right? Yeah, we took out the diodes. So if I can get these drivers to work, then no diodes, hopefully no noise, get the big motors running on it efficiently, and we'll see where that gets us. Oh, that means I need to redo the FET board to have 2 N channels on it. Well, I have 2 N channels, but they're both on the low side. Can I power them? One on the low, one on the high? I might be able to just do it on the breadboard. We'll have to take a look. We'll have to take a look at what I've got physically configured on the board itself here that I can whip up for a test. Which means I guess we got to take all this stuff out. I've been coughing lately. I don't know what the deal is. Voice just got a little bit gravelly, I guess. Yeah, I'm gonna break all this down except for the radio input. Bow, bow. Cool thing is, with the high side driver, that means that we don't need the inverting transistors on this anymore. You guys see that Tom Thinks is on the front page of Twitch again for like Artist Week? Pretty cool. Like 7,000 people watching. Craziness. Craziness. That guy's got a good audience now. I'm so happy for him. It's about damn time too, you know? That stream should be protected at all costs. Right, okay. Not much else here. Everything's kind of broken down, ready to figure out what the heck's going on this thing. See if we can't get FET drivers working. What's up, brunch noodles? Streams during news time? You know. What are you gonna do? Yep, FTL music. Classic. Timeless classic. Also video game music, so it's not gonna get flagged. Like, the spots where my fingers were are warm, but my fingers themselves are cold. Why are my fingers so cold? Why are they so cold? They don't feel cold. It's whatever. It's a global emote? Weird one. Yeah, that is a weird one. Wonder what it costs to get a global emote, you know? Without being like a super popular streamer, like if I could just do a promotion and everybody gets like no bother emote. Like those Hex Drive whatever emotes that we have from some promotion a billion years ago. Oh, did I close the... Yeah, I closed the model. It's alright. We don't need Fusion that much today. This is what we're looking at today. But I'll wait a little bit to start, because, you know... I mean, I guess I can just jump into it. I don't think I'd lose anybody, but I like to let people gather a little bit ahead of time. Get my head in the game and everything. I'm gonna wake up. Let you guys do this kind of stuff. Hey, Kinders, thank you for following. Ugh, all the parts for that wonderful piece of rack mount equipment. I think maybe someday, if I decide to like build some rack mount device, I could possibly use the enclosure for this thing and the power supply, and maybe retool it to do stuff that I needed to do. But I'm not in terrible need of like 1,000 BNC connectors to connect anything though. And that video recorder was all BNC connectors, so could replace them with RCAs or something. Right. Should we just like get going? Because I have a lot of work to do today. I have a lot of work to do and not a lot of sleep under my belt for some reason. I've just been drained. I've been super drained the past week. I don't know. I got some like checkup doctor's appointments coming up on like Monday, and gotta get blood drawn tomorrow. I think I'm okay. It's just I just had some weird shit going on, and I'm like starting to get back into my routines. I need a vacation. That's where we're at. All right. But what would vacation be? It would be sitting around here. That's what I do anyway. All right, let's get started because might as well, right? Let's lower the audio by hitting a button on something somewhere. Which tab is playing audio right now? There we go. Found it. That's kind of eerie beginning music. Maybe I need to choose something a little bit more punchy. Let's get rid of start soon. Ready to go. All the cameras are calibrated. Everybody looks good. I got audio coming in. It might be a little scratchy. I'm seeing some red on there, but I think I'm okay. Yeah, welcome to another week of streaming with me. Hopefully this time we actually do a Thursday stream, because yeah, it's kind of dumb that I haven't done one in a couple weeks just because stuff keeps coming up to mess with a Thursday stream. Thursday, I really want to work on this computer. This thing should have been done by now, right? This computer should have been done. A computer that goes in the rack case that's going to go in the rack. It's going to hold my streaming computer. It's a very simple water-cooled setup that I want to do some of the panels for the front of, and use that hexagonal grating that I bought in order to make just kind of like a cage that'll hold all of the computer stuff. And of course, it needs to also hold the platter hard drive that contains the stream archives. So that's going to be a little bit more challenging, but not that hard to do. We just have to do the work. And then I got to do a little bit of 3D printing in order to make the parts so that the thing has that unique look that I'm going for. That's not hard to do. We just haven't had a Thursday to work on it. Tuesday, today, RC car stuff. I got a MOSFET N-channel high side driver, low side driver. It's a little chip that goes between your microcontroller and your MOSFET. And if you're getting just basic MOSFETs, if you're trying to just use basic MOSFETs, I say basic. Basically what it does is instead of using a positive side and a negative side MOSFET, you just have negative side MOSFETs, N-channel MOSFETs, which apparently are better. And this thing is able to kick them into drive. It punches them with a higher voltage. At 3 volts, this thing will hit it with like 9 volts or something like that. It's similar to that. But what it does is it allows the FET to be fully switched, which is important because when we got that RC car motor running last time, it wasn't really running at full tilt. It was kind of not running well at all. It was actually quite slow. And in previous iterations, we would run it, and then something would kick out all of the electronics, some kind of noise. So part of what this thing is supposed to do is get those FETs to switch off and fully conduct electricity through them. It gets them to really, really switch. I bought this part after looking at DigiKey for 45 minutes. I didn't realize how small they were. I mean, yeah, all the documentation says 1.2 millimeter by 1.2 millimeter, but have you really sat down and gone, how big is 1.2 millimeter square? It is really small. There are 4 contacts on this thing, and it is a very simple chip. I've got 2 of them down on a piece of prototyping board that'll plug into the breadboard. I would like to configure more stuff. We need to get the end channels ready to go. Yeah, 4 contacts on that size. Yeah, yes, it is a gate driver. That's literally what I just said. But yeah, so I want to get all that stuff running onto the breadboard. We're gonna have to do a little bit of soldering though, because I don't have high and low side end channel MOSFET set up. I don't know if I can do that because they're both going. Yeah, I'm gonna have to. I'll have to figure some stuff out. We may have to bust out some parts and reconfigure my little board that I made the other week in order to get that test up and running and see if this works. I hope it does, because that means that I can get into the more interesting stuff. And the reason I'm choosing individual grain of rice is like twice the size of this thing. tdroque, hey, thank you for the 11 months. The reason that I'm looking at individual gate drivers instead of a combo of like 4 gate drivers in one, individual gate drivers because of the space. I don't necessarily have space to put down a big surface mount part. Putting a little 4-contact surface mount part and peppering it throughout the board will work. But yeah. Hairbrain, 7 months. Hell yeah, dude. Thank you guys for the Prime and the 11-month regular sub. Appreciate that. Let's put you guys up on the board. Now, earlier we had Not a Bag of Milky Ways take a full minute to place. It looks like both of you guys placed pretty quickly, though. So these slightly longer names are going to start to take longer amounts of time. Concerningly. At some point, I'll have to make an executive decision to take the board down. That's getting soon. I've been putting that off. I don't know what the exact timing is, but it seemed like it was approaching a minute. tdroque, welcome to the board. And then Hairbrain, going up here. Welcome to the board, both of you. 11 months and 7 months. I really do appreciate the continuation of subs. You guys are great. Super cool. All right, so let's take a look here. So what I've got currently is a little board that I just made. There's all too much stuff on the screen. Hold on, let's just go straight to the micro. There we go. It's crusty, crusty, crusty. All right, so here's the 2 parts. Here are the 2 parts. Now they have 4 contacts on them. And I did my best to solder them in. Excuse me, this cough has not gotten better. It's just been like a constant. So here are the 2 parts. These are the 2 FET drivers. They need a capacitor across here. The part number, if you're looking for it, is MIC 5019. Right there. You want to see what we're up against here. MIC 5019. I have not tried these. I bought a bunch of them. I also bought more N-channel FETs, but they're on back order. Apparently everybody bought up all of DigiKey's supply of these things, so I don't know what I'm going to do about that. These have 4 contacts on them, and they are on the edges of the chip itself. Okay, why did you stop? What the? God, it was scrolling at just a fine pace until I had the audacity to mouse over something that stopped it from scrolling. So these right here, that's kind of a big circuit. That's a big test circuit. Yeah, 4 contacts, and they are on the edge of a 1.2 by 1.2 millimeter chip. So that's what I'm up against here. And I've put those, onto these little boards where there barely is enough room between these holes. Now, the 0.1 inch spaced perforated prototyping board that I have with the square contacts, that gets about this close as well. Here, where's that? I had a little piece of that board. Here it is. So I don't think I could switch it up. I don't think this will get me any closer. That's about that same spacing. Yeah, so there's not really much that I can do about this until I build a circuit board myself. I'm pretty sure that these are making good contact. I don't have a soldering skillet would probably be the best thing for this, because then I tried to use hot air, and hot air just blew the chip out of battery. Basically, it just blew it to the side. I'm moderately sure that I've got good contact on the edges there, but there's no like surface tension wicking going on here for me to observe. I can tilt the camera and take a look. No, glue would not help. I could flip them upside down and try to connect them with wire, but I don't feel like messing with the wire that's that small. I could basically flip them upside down, not really know which contact is which, but then also use cut a braided wire and remove individual wires, and then I could just bridge that contact over to there. I could even do that right side up. But I mean, I could, one little dot of glue and then flip it over. Dead bugging this would probably be our alternative today if we have a lot of trouble with these. Right now, I'm just going to deal with it the way it is, right? So just going to deal with it the way it is. I think I've got good contact on these. It took me a little while to master that. Hot air was a bad idea because it blew the chip away. A skillet would be perfect. I don't have a skillet, so I couldn't do that. I don't know. There's probably other methods. Iron upside down, like a skillet. But anyway, we're going to try these out and see if they work. But first, I need N-channel FETs to be able to drive my motor. So here's what we built previously. It's all the way on the other side of this thing. There it is. Here's what we built previously, and this is with the special super duper whatchamacallit chips. We've got the N channels over here. These are the FETs that I want to use. They're very, very small as well. So these are the N channels. These are the P channels. We need to replace the P channels with N channels, and I don't know if we need this pull down anymore. It didn't. Like concern trolling. I've never broken a chip through soldering like that. It's just the FETs aren't like that. Okay, so these two, I think maybe we just remove them and I try to replace them and see what the pinouts are gonna, where the pinouts are gonna land. I just all right. Okay, chat. You're so full of counterexamples. It's great. I love it. Love every second of it. Every second of every sentence that I say. I love talking to you guys because you're so fun to talk to. Yeah, so anyway. God. So fun. They're not calling for pull downs in here. No, sorry, we're replacing the P channels with N channels. I got that wrong. Every little detail. Every little detail. Do I need to put footnotes on my footnotes for you guys? See, they're not in any of their circuitry. They're not giving me a pull up or a pull down. Yeah, I understand you guys know what I'm talking about, but you don't need to counterpoint every point that I make. We're already dealing with a niche subject here, and you're going to scare people off. So, all right. I just want to get the circuit down, and there's no call for a pull up or a pull down on this thing. And what does the internal circuitry look like? Maybe there's an internal pull up or pull down. I just can't bring myself to care. Charge pump. We got a Zener. The output doesn't really hint at there being anything there other than, I mean, this is just like a simple breakdown. It's not the real thing. Lord knows there might be a pull up or pull down. I'm just not going to put it in. I'm just not going to put it in. So yeah, we'll get rid of the pull-ups or the pull-downs and... Oh my God, thank you, Zap Rebel, finally weighing in on this topic. Am I allowed to proceed? Okay, all right. Let's stop being as prickly. All right, so I'm not gonna do a pull-up or pull-down, and we're gonna wire N channels in there. I'm just going to put one in, but I'll remove both of the P channels so that we don't confuse ourselves. I don't want to leave like remnants of circuitry in there. So what we're going to be wiring is essentially this, but without half of the channels. So we're just going to have forward on this. So it's like I don't need one of these, I don't need one of these, and then I don't need the corresponding drivers for that. We just need the one channel to go in one direction across this thing, right? And that's going to help us out because a lot of this stuff is way too fiddly. If we run into noise problems, I'll have to build the whole thing, but we'll keep that in our back pocket. The pull downs, however, will be on the opposite side of the gate drivers because those are the default states. Even though the microcontroller will technically pull those down, if something happens with the microcontroller, it doesn't get enough voltage or whatever, I don't want that to instigate drive through the gates because it's a floating pin, right? So the pull downs will be on the microcontroller side, which I don't think we have. No, we do, but we won't. Okay, let's get to work. Let's get to work. So multi-view. Do we need to be this close for these? No, we don't need to be this close. Let me get the claustrophobia away a little bit here. Oop, okay. All right. Let's get the soldering iron out. Let's get started. So the ones that I need to remove are the ones with the 2.2K pull-up resistors. They're not really pull-up resistors. They're just connected to this channel. That's all. We're going to use this spot here, but those pinouts are going to change. So let's see. Tweezers, soldering iron. I've got the absolutely minuscule tip on these, and if I'm going to be reworking this, as in removing stuff, I think I'm going to need a little bit more surface area for my soldering iron. So let's get the larger soldering iron out here, and I'm not going to go too far. I think I just need that little blunt front tip. Why are we all the way over to the left though? We need to move to the right. I'm going to slide to the right a little bit here. Why are we so far over to the side? I think it's just my microscope's just been migrating over there. Let's move back over here so I feel like I'm utilizing more of my desk space. Jeez. Like my screen space is also being completely taken up. All right, I'm gonna cough. Micro soldering, let's go. Let's effing go. All right, so what I'm gonna do here, oh yeah, we'll turn on the iron, step one. All right, let's see. Well, the resistors are the easy ones to remove. I think I'm just gonna grab all of them, remove all of them. I haven't even taken the parts out for this yet, but yeah, so simple stuff, surface mount resistor, both sides, heat, and eventually the resistor will just move out of the way. So I'm heating it and nudging it with the iron just a little bit each time. And eventually that's gonna lead to this thing flying off. I wanna make sure that I keep track of which one's the N channel and which one's the P channel, because it's these are built exactly the same. All right, so I'm gonna try putting a little pressure on the side here, and then just trying to skip back and forth. In the past, I would add a little bit of solder to this in order to make sure that they both get to temperature. Maybe I just need to wait a little bit. Yeah, this stuff is clad on both sides, and the vias are through. So I think the heat is probably dissipating pretty nicely from side to side on that, which is why it takes a little bit. I mean, I guess I could use hot air and then I could just pluck these things off, but I can't use hot air on the perforated board. It'll melt it. It'll melt it almost immediately. Oh, come on. There it is. Yeah, usually you can just kind of roll them off. Resistors aren't really necessarily worth saving. You don't need to keep like derelict resistor bins for surface mount resistors. They're fairly throwawayable, even this day and age. Now, removing this is going to be a bit of a challenge, isn't it? I'm starting to wonder whether or not I need to think about using hot air. At the very least, I could just load it up with solder and then it'll run away. I kind of want to keep the P-channel FET, though. I'm not sure if we're done with them or not. We might be, but we also might not be. I need a little bit more solder right here. You can see that the heat isn't spreading as well as I'd like it to. I need that heat to kind of propagate. And I'm leaving the 10Ks in right now just to mark them, because, oh God, I don't want to lose track of which one's which. All right, I'm going to let that heat up for just a second. Jump to its buddy over here. Try to get both of these at once, maybe. Yeah, it's dissipating heat really well, which is the whole point of a FET board. There we go. All right, so we got one of them up. You can see I pushed it a second time there just briefly to make sure that it wasn't going to bond to anything. Now I'm going to put that in a special spot. Onto its buddy over here. Same deal. Same deal. Just add solder. I'll probably take solder wick to this to clean up these pads so we can put the end channel down. Is that even what's going on there? Okay, there we go. We got to refresh the flux. Refresh the flux. What? The flash. I've been checking out Vermintide 2 again recently, my gaming friends and I. Which is always fun, because I get to do a Victor Saltpan impression the whole time. Yes. You should be thankful that I'm here. Those voice actors must have had so much goddamn fun in that game. All right, there's that. So those are the old FETs out. Get a little desolder wick on this. Ad said you needed to renew something. What? What? You gonna make your own PCB? Do you have your own etching? No. No. The services are so much cheaper and you don't have to store chemicals. Almost an engineer. Let's get you up on that board. Thank you for subbing. Trying to clean off these contacts right now. Hold on. All right, let's get Almost an Engineer up on the board. Bop, bop. That's a slightly longer name, so it might take a little while. Let's see. Let's see how all of the different algorithms handle it. Here we are again. This is going to be the story for a little while. There it goes. That was actually relatively quick. Almost an Engineer going up on the board. How long has this been? 16 months. Oh yeah. Good stuff. Going by Mr. Button 37. Yeah, I mean, building a board at home is just fraught with errors and nonsense. If you're trying to keep your designs super duper secret, maybe you could play around with, you know, etching your own boards, whether it by mechanical means or by etchant solutions or by laser printing and all that stuff. But I mean, honestly, like you can design your model, your board in CAD, send it to a place, and you're out like $20. For me, it's like $35 if I get bad shipping. See, it does $5 for 10 boards, but you're best to ship them with DHL. Otherwise, you're not going to see your boards for a long time. And when you ship it with DHL, that's like $25 in shipping. So it's not super duper duper. There are services in America that everybody's going to be talking about now in chat and naming over and over again, and I'm sure they're fine too. There's JLPCV, there's a bunch of others like that. I haven't vetted them out personally. I've used Seed Studio, but I'm sure they're just as good. But yeah, anywho. All right, so back to soldering. I need to clean up these contacts. Bop. It does look kind of gross, but it is a test board after all. How often do you need more than that, though? Yeah, it's like, I mean, the panelization is super nice. I don't, you know, I'm usually building prototypes. I'm not selling the stuff that I build. If I were selling, I don't know what I would do. I don't know what I'd do. All right, desolder wick. There we go. Just trying to clean these up so that they're flat, so that I can get good contact to the new end channel FET that's going to go in there. It's a little bit more of a struggle with this smaller iron tip. D solder braid. Ugh, that's a mess. That is a mess. I think I could clean it up better with a larger tip. Also, yeah, a little tacky flux probably would go pretty far on this. Well, yeah, I mean, cheap or expensive desolder braid. I think the difference is just what they're putting on the copper braid. In which case, I have just bridged the gap by splashing it with a bunch of tacky flux. So, yeah, cheaper, expensive desolder braid. But I usually get Solder Wick brand. This is, or whatever this stuff is. Chemtronics. There we go. They've got chemical and electronics in the name. It is. Sometimes I'll use the braid to make high current traces, but other than that, yes, it is just a one-time use item, which is pretty wasteful, but then again, I don't know, how much scrap wire do you have sitting around? Why is this not soldering at all? What the fuck is going on? I'm gonna get a larger iron tip on this. I'm just gonna go for broke here. I don't know what's going on. Like, heat just wasn't getting in there. Frustrating. All right, wait for the heat, wait for the noise. Let's get you guys a little closer over here so you can see hand techniques and stuff like that. You can see the heat propagation and whatnot. Ooh, there's a plastic smell. I wonder what I was doing with this last. Many thanks. What was that? Many thanks, brah. Thanks for following, dude. All right, let's get rid of some of this. Bruh. I don't know. I'm just not. That's just not cooperating. I'm just not gonna bother with it. Solder braid should come with a Rossmann level of flux. Possibly, yeah. Yeah, that's exactly what I'm doing, yeah. I'm not worried about the excess of solder. What I'm worried about is the height of the solder, because we've got a QFN well, a weird QF no. We've got a weird no lead package that needs to go in here, and so these need to be flat. That's going to promote contact among all these pads, all of these pads. All right, so what's going in here? Now these are these micrel parts that I bought. Let's see. Let's see if I can find the case of them. One sec. Got them stashed away in these bins. Once I find it, we'll be able to look up the data sheet so I know what lead is what. No, I did. You got it right. Yeah, that's what I did. That's what I did. Where are those things? ITC port, desoldered, SPDT, JVLMP, 2N3904. Where are my parts? Where did I put my parts? Let's see. High speed amp. No, I don't think that's what we're gonna need. I don't think that's the part that we need. I think we need a slightly different part. I'll show you guys why I'm my insanity in just a minute here. I need to find my parts. That way we can actually put them in. Boom, 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 boom. High rose crimps, tinies, LEDs, ferrite beads. Resonator, no. Light core caps. Good AT tinies. Nope, 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 nope. Somewhere around here I've stashed Shocky diodes. Don't tell me they're in an unlabeled. I think I labeled them. Maybe I didn't. If I didn't label them, I'm going to be annoyed at myself. I'm going to be quite annoyed at myself. Pretty sure that I labeled them though. Dual rail op amp, not what I'm looking for. I've got a drawer here that's just filled with these little bins of bins. These little bins that are full of surface mount parts. And I'm sort of looking through to see where I put these FETs, because they're specialty FETs. And I only have so many of them. I think I bought like 10 of each. I didn't leave them in the packaging. No, that's not it. That was for another project a long time ago. Let's see. I think I labeled them. I'm pretty sure that I labeled them, right? Logic FET, SOT23. That's not the right one. These are like, well, I've got the part number in CAD. I can open it up there, but I need the actual NFET to plug it into this circuit. So we can get this motor thing going. Figure out how to get all this stuff rolling, right? Yeah, one thing I've learned with parts, if you need 10 by 20, I thought my H-bridge was just gonna work, and then I'd have an excess of these little guys. But no, I don't need an inventory management system, because then I have that on top of everything else. My inventory management system is just being organized with the bins. Usually that works out pretty well. It's just things are a little discombobulated right now. They, you know, there's a possibility that they are indeed in an unlabeled bin, which means I got to start really searching for them. Because I expected to. I thought I made labels for them though. P, Hall sensor, LIN receiver, Digipot, LIN receiver. No, 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 no. Nope, 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 nope. Those are steering wheel parts, by the way. Let's see. Oh. Nope, that's resistors. I had big kits of surface mount resistors and stuff, And I put them all in those little Wentai bins, and I don't think that was a good call. I don't think it was a very good call. Now there's stuff in 2 of these bins, more than 2 of these bins. Clocks, what's that one? RF stuff, nope, double nope. Yeah, these are the SparkFun parts. All right, I gotta find these fucking things. I'm actually going to start digging inside of this bin here till I can find the right part. Because yeah, I don't think I did anything too crazy with them. I think I put them in their own little bin. Why is my phone ringing? Oh, it immediately went to AT&T free message. Your new cell phone should have arrived by now. Let's activate it. They think I'm still on a 3G only phone, so they sent me a new cell phone worth a whopping $35 on eBay, and I need to activate it and a new SIM card. I didn't call them in time for them to not do this, but apparently they still think I'm like on a grandpa phone. All right, no FETs. Where are my FETs? Did I have them in a different bin? Were they like up here? They might have been. This is the problem here, is I've got these parts that are absolutely tiny, and they're one-of-a-kind-ish sort of things. So I can't just like find a generic replacement to go in their place. I took them off of the tape, and I think I put them into bins. The question is, what did I do with those bins? There were 2 bins that were like of these little surface mount boxes that were kind of floating around. So the thought is, what did I do with it then? Did I clip it to another collection of bins, or did I put it aside on its own because they were special for the RC car project? I don't know. It would behoove me to figure out what I did with this stuff. I don't think I put it with the rest of the RC car stuff, because it's strictly, yeah, that's more RC car sort of flavored stuff. And so the other places that it would be, I don't know, like at the back of my desk, maybe. Just take a quick look here. Well, there's that cell phone AT&T sent me. It really is a piece of garbage. No, don't see them. Okay, all right. So the strongest possibility of where these parts are is probably on the bins, and I probably just looked at them like a second ago. They might be in unlabeled bins, which is a bit of a problem. Why am I so tired today? God. I think I got sleep. I'm just like fucking. I could take a nap right now. I could do that. Maybe we'll have a social sleeping stream. Sick Ab did that once, and I thought he was fucking dead. I was like, did he die on stream? What's happening? Why are you doing a social streaming stream, you weirdo? Anyway, all right. So yeah, let's find these parts. They're crucial to moving on from where we are right now, because what I need to do is wire up these end channel FETs. For those of you who weren't here earlier, I found this special part, the MIC 5019. What that's designed to do is pop up the voltage just a little bit, so that when our FETs switch on the motor, they switch on fully, right? So the FET, like with a FET, sometimes you need a driver for it. If it's not a CMOS compatible FET, you need a slightly higher voltage in order to kick it off, in order to have it fully conduct. I think we ran into that problem when we tested it previously. I'm not going to do like numbers calculations, so I just bought some parts and we'll try them out and see what happens. So we're going to try this FET driver out. That should kick on the end channel FETs and hopefully allow the motor on our little RC car to run better. We ran it directly off of CMOS, and the motor just wasn't fully doing its thing. I think the previous MOSFETs that we had in that circuit, the ones that were provided by wltoys, were in fact CMOS compatible FETs. So they would automatically fully conduct at whatever the line voltage was. So love profiling my older self in order to find out where I would have put stuff. That's pretty much where we are, right? What would I have done? What mindset was I in? What would I have done? And the other question is, have I been tripping over these bins for the past month, and therefore they ended up in a weird spot because I decided to put them somewhere else to get them out of my own way. But I don't see any of the bins conspicuously hanging out in any of the normal parts dumps that I have sitting around here. We need to work on that Nixie circuit. We should do that soon. I'll put that back on the docket. And I need to do a water change on Burn the Subs. All right, so let's try to find these drivers. What these are is, what were they? Actually, I've got the part number here. SIA 400 EDJ. These little bastards here, these things, they're pretty cool though. They're very small. They dissipate heat extraordinarily well from what I've seen. They can really command a lot of current around. 65 cents a piece plus a 70-cent driver. The costs, they start to stack. It's been a fun project though. I've been able to kind of work with motor stuff a lot on this in order to create my own little boutique motor control circuit. So SIA 400 EDJ, that's what we're dealing with. We're looking for those. So I'm looking for a bin that's labeled either N-channel MOSFET or SIA, or just has the parts in it. Well, I need to figure out how many of these I actually still have. Hopefully enough to continue. I mean, we probably have enough to continue today, but I also back ordered a butt ton of them. They're coming in the mail. I don't know when. I don't know when they'll get the back order in. Okay, so that one's a no-go. This one I redid this whole side, and then all of these connectors fell out. I had a bunch of these like high current connectors in this one, and they're all gone now. They all fell out into the bottom of the bin. Any pieces of tape and reel in here? There's 0.1 UFs right here, and one button. I need to organize this again. This is just like a miscellaneous one. Digipot, LIN receiver, Hall sensor. None of those are relevant. All right, up. That's not them. That's some voltage regulators. Nope. What are you? You don't look like the right part. 1% resistors. Those are for a current sensor. LDO, opto isolators, Zener diode, electron, blah, 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 EPROMs, miscellaneous desoldered stuff. All right, so none of that. Next, this one is a little bit wacky. There's a lot of crystals in this one. A lot of crystals. I guess they were from that miscellaneous... Oh yeah, all my jumpers. We don't need jumpers anymore, do we, in motherboards? It's like as soon as I started to collect jumpers, we no longer needed them in motherboards. Oh well. I should use jumpers more. Yeah, nothing here. What the hell is that? Huh. Okay, anyway. Logic NFET, but that's not quite right. Amp, diodes, blah, 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 blah. Yeah, none of that. None of that's the right thing. I'm starting to feel like there was like a collection of 2 bins that I put somewhere. Yeah, like on the back of hard drives and stuff. I remember those. These are accelerometers, and then I think below them, yeah, just a bunch of other miscellaneous chippy stuff. That's not them. That's not them. That's not. I gotta clean these out, man. These are nasty. That's not them. These are the tiny fans. Those are expensive, those fans. Those things are not cheap. What is this? Nope, those are different parts. I don't even know what they are. And looks like a couple Hall effect sensors too. You mean this thing? There's a command to see what it is. Thermals. But it is a lepton. Shockies. Shockies. What has this been? This one has some stuff in it. No. Nope. No. Nope. Nope. Buttons. Those are buttons. No, those are crystals. Or coils. Switches. I got a bunch of switches. That's nice. Those are those Pololu motor drivers. Op amps. Man, you know, like I thought I had these. I thought I had these just like easy to find. But apparently I proved myself wrong on that. AT-Tinies, LEDs. Not in there. What did I do with these? It's a Schottky diode, so it's not even opening. Jerk. No. Oh, that's the other thermal camera. Aha! Here they are. Yeah. Okay. Found them. They're there. Of course. Yeah, the thing that's driving thermals right now looks a lot like this. This is a thermal webcam module. It is a very small thing. I had to make my own 3D printed enclosure for it so that it would be safe all the way up there on the boom arm with the camera, because I would constantly brush up against it and then it would fall out of the terrible reverse, I don't know, I don't want to call it reverse engineer, but it's like the socket is not sold by Molex. It's like the socket's not sold by Lepton. It's made by like Molex, and it doesn't really grip that thermal imager very well. There's not a lot to grip on that thermal imager, so I'd brush up against it and it would literally fall out of that socket, and it got damaged over time. So eventually I bought another one on eBay. They were like $150 on eBay for some reason. So I got another one, and then I built an enclosure around it. So now this one is protected. All right, so the P and the N channel I haven't labeled in any way, shape, or form. Smart. So I don't know how much I have of either. Which means we need to get close. We need to saddle up close to one another, chap. We need to figure out which one's which. Because I got two P channels right here, and I guess I could put these probably back in the bin, as much as I hate to do that. But let's get these organized into P's and N's and figure out how many I have. Because I need 4 per design. I'm making 2 official ones for the actual RC cars, and then I've got a 3rd test one. It's 12. Since I don't think I have 12. Let's get close. Get nice and close. See what we got here. Put the camera all the way down like this. Each square on this thing, by the way, is 1 inch. So we're viewing at about a square inch, a little bit close to that. I'll try to straighten that out a little bit. There's a little parallax going on here. All right, there's our dot. I don't know which dot it is. Here they are. All right. So BKW. We'll figure out what that means in a second here. Wait, why can't I move the tweezers to the left? What happened? I got caught on something. All right. BKW. Oh, it's getting caught on that little, there's like a little printing error in the plastic. All right. Let's pick that guy up, flip him over. Boop. So BK and A1. I have a feeling these are the P channel. Actually, we can find out by me just pulling one of the P channels over here. Okay, that one has had a little bit of flux on it, historically. It's all chewed up. Yeah, the BKWs are the P channels, which we don't necessarily need. Great. Of course, I've got an abundance of those. Oh my God, these are like all these are all P channels. I really I have that few N channel. I have 4. Great. Okay. All right. We can work with it, I guess. Look at that. 7 P channels and 4 N channels. Where'd the other ones go? Well, technically we only need 2 if we're going to build the full H bridge. So let me grab 2 of these. Put them aside. I almost lost my voice over the weekend, so that's why I'm a little coughy, a little scratchy. All right, so yeah, those are those. We need to put them in here. Let's back the camera out a little bit so that we're not viewing the dust in my shop at full 4K ultra resolution. Luckily, Twitch doesn't do 4K, otherwise we'd all be out of hard drive space. Is it good to wear a mask or face shield when working with those tiny parts? I don't know. I don't do that. I don't know if you need to. I'm currently, I mean, you have to know that because I'm filming this, my face is behind the camera here. So I'm actually pretty far away from all the stuff that I'm doing. This is where I'm working on the parts. And you know, I'm looking at this monitor, which is up and over top of the desk. So my back is straight. I'm sitting upright. You know, I'm fully extended. I'm ergonomic. My wrists aren't at weird angles. Why is that one wire right there? You worried about sneezing, coughing, and blowing them away? I'm not that close to them. I can sneeze and cough and it won't do anything. All right, so what are we wiring up here? Well, we need this. So I need for my positive voltage lines to go to the drain, which is weird, but that's what's in the data sheet for the micrel part. That goes to the drain. Is that correct? Yeah, that is correct. It goes to the drain. So the big pad is going to the motor line. No, the big pad is going to the power line. And then the small pad, the one up front, is going to the motor, and then this one's hanging off on the side. How are we going to do that? That changes, okay, so that changes the layout here of this board, because I didn't break them out individually, right? So I have the motor line as this big guy, whereas if we redo it, I could change that over to the other one. So the drain in this case goes to positive power. If I keep that as the motor and I do the drain as going to positive, that would mean that this here, and then the gate is the one on the left. So then if I do that, like, that doesn't work. That doesn't really work. Think about this for just a second. Hold on. So, I mean, I can fit that like this. Come on, man. Think. So, yeah, not a lot of good options here. Because it's not like this is split. This is just the big shared one. I mean, I could turn it up on its face and, yeah, that's what I was just thinking. Dead bug. Because, yeah, the big pad goes to positive power, and then the one on the one tiny pin that's on the top, northmost, that one is the trigger, and then the two below it are, no, sorry, the one all the way at the bottom is the trigger, and then two above it are the ones that go to the motor line. So if I flip this over, that would mean that the top one has to go there, and then those two there. It doesn't really work. But if I flip it over, that, oop, no. Come back here. If I flip it over, that means that that one goes to power. These two go to the motor, and that bottom one goes to the thing. So I could do power here, those two there, and then this one here. I don't really want to dead bug it though. That'd be really sloppy. This is what the diagram that I'm provided with, by the way. It's not exactly the easiest thing to interpret. You got to do a lot of spatial thinking when you flip these things around and start messing around with them like this. So in this case, oh man, this is where it would cost me $30 in a week and a little bit of design time to make my own test board for this. This absolutely does not call for having a custom PCB made. Cut the traces, maybe. Maybe cut the traces. I think just a little piece of wire on that would be okay though, right? Oh, I really got a cough. I don't know why. Sorry, a big lead up to that because I missed the button. I ended up making like a noise. All right. I mean, I can desolder this. That's fine. This is what I was interpreting as being the motor line because that's where we're dumping all of our heat. If I cut that, see, the problem is this bar going across is going to short out to this. Yeah, I mean, I could move them to a different proto board. Hey, get off. Yeah, move them to a different proto board would be one strategy. I mean, if I do, if I flip it over, most of the contact there, and then just barely get one over to the other side, nah. Yeah, these are characteristically very small. That's the whole purpose of them, you know? I mean, I could do it across here. These three. And then subsequently it would probably be, have to figure out how to do it on the other end. Because, yeah, okay, which one's the gate? So if we're looking at it, why do they give me that view that way? The view of it is like, I'm not sure I understand the footprint. Yeah, it's a no lead footprint, but it's got a big omni like shared pad. It's a certain type of surface mount device, and then they bridged the pins over. So we've got the 4 on the back end there, and then the 3 on the front. Technically, it has 7 pins, but those 3 on the front, 2 of them are the source, and then 1 of them is the gate. So the front right, if we're looking at the back legs, so I would make this one the gate, which would be oh so convenient if I could just solder that down directly like this. And I can do that on the other side of the board. Maybe we should do that, because I could solder that down just like that, and it would be on the other side of the board. This one would go like this on this side of the board. That would work like this. If I do one on the top and one underneath, then I can do it this way. So I can have that as my power. This is my gate. This goes to the motor as source. So that one can go like this. And if I need the other one, I can do it on the underside of the board in the same way. Yeah, if they joined the pins, it would visually be easier. But they're not worried about it being visually easier, because this stuff exists in CAD only. They don't expect you to be physically soldering this stuff like I am. All right, so to double check. Double check. According to this thing, that pin on the left is the gate. That we want in alignment here. And then the sources will go to the big pad, and then the drain will go to the upper pad. And the drain is the power source, and this one goes to the motor. And we can use this as the other side driver. Man, that is annoying. Man, that is annoying to wire up, isn't it? We probably have utilized more of this type of board elsewhere in order to put these together logically, but right now we're just trying to kind of play makeup here and figure it all out. Okay, so let's try to get this thing soldered down. We'll do one for now. Let me put the other one away so it's in a safe place so I don't accidentally get it stuck to the bottom of my hand, which happens. And then we'll only wire up one side of the motor controller, and we'll figure that out. Because we'll do the two. I'll get rid of the pull downs once we get this thing in, and then we'll wire this one and this one up to the motor so that we have a high side and then a low side. I forget which one of these is which, but we'll figure that out later. Louie, how you doing, man? How you guys doing? Ran with a party of 18. Dude, Louie's been making a Game Boy game, which is freaking cool. You guys should absolutely go check him out if you get a chance. I'm a little hoarse today. I don't know what happened to me. Sleeping, I guess. I don't know. This weekend almost took my voice away, so we're having a chill time. We're working on tiny little RC cars. Oh yeah, he's playing Factorio. I saw that the other day. Tiny little RC cars that I've been 3D modeling and doing all kinds of crazy stuff with. Right now, we're actually just trying to get the electronics to run the motor, because it wasn't quite running the motor as well as I would have liked to do. But yeah, this is the wltoys 989 kit, and I've been going a little crazy with this. I kind of need to refocus and stop doing RC cars so much, but it's addictive. It's addictive because there's a lot of cool little like engineering projects in this. But yeah, I've been 3D modeling this RC car so that eventually I can put a cool looking body on it. But also so that I can fit all the electronics, I can stuff them away into this corner of the whole thing. And so this has brought me through to, learning how to build 3D models of stuff and grab stuff from GrabCAD and, doing all the measurements and getting it all exactly right. It's been pretty cool. But yeah, so that should allow me to put some kind of cool body on top of this thing. Until then, we've been working on the electronics, and the electronics have not been working out so well for me. Everything I try seems to be doomed to dying. We built a motor controller. We programmed that ourselves. It's in the ATtiny85. So it's like a lot of code went into that, a lot of tweaking and stuff. And it works. It's just that I'm dealing with noise problems with the circuit. And so I've found these specialty components, these boutique components that are very, very small and very, very effective at what they do. They're things that switch power to the motor, which is this thing over here, which I've designed to go in a particular way, right? It's using a slightly different motor than the kit comes with. And so in order to utilize that motor, I've been using these just absolutely painfully tiny FET drivers, these things right here, to try to get this thing up and running. We got a full test going on it. It didn't work so well. The thought is that in order to switch these silicon switching components, you need to kick them on and off. They need a higher voltage, so they need a specific driver to work them. So that's kind of what we've been working on. But yeah, a lot of the efforts previous to this have been with mounting all the hardware to this. So that's what the Fusion CAD model has been, is designing parts like this, parts like this thing here and this here to hold the servo and the motor that I can 3D print. So I've been doing little like supplemental engineering kind of stuff, or to get this all rolling. But yeah, anyway, I hope that's enough explanation for all you guys. Thank you for the raid. I hope Factorio's been treating you well. I have a couple little things that I need to do with the gaming setup, and then I really do want to actually stream some frickin' games, because yeah, I need to change it up. I need to change it up a little bit. I need to change my MO. We can't just continue to do this stuff all the time. We can, but I do want to actually just like relax for once. So anyway, we're trying to get what's called an N-channel MOSFET soldered into this thing. Typically, you don't have to work with. Oh, this is the wrong soldering iron tip. That's not going to help. Typically, you don't have to work with stuff that is evil, this evil and small. Right? This is evil small size. But I have decided to do this because this is sort of like the final stages of getting the circuit board design down and locked in. I need to make sure that the parts that I have are in the right configuration in order to do the job that I want it to do. And then I can actually I can finish designing where all the traces go and everything on the circuit board, and with the eventuality of sending it out to a place to get printed, and then build it myself. I made it myself. Yeah, so the Mario Kart project has gotten a little bit out of control. I don't know if it's really the Mario Kart project anymore. I don't know if that's really a thing. That did not solder down at all. This is going to be tough because I need to somehow make sure that this thing contacts all three of these without shorting. The pins on the bottom of this thing are very, very small. I need to, oh, it looks like I did. Yeah, I got those two on the right to actually make contact. And then I need to get the rest of this thing to make contact too. Well, let's try it. Let's try it. Small but effective story of my life. All right, let's see. Let's get this thing right there. Hopefully. Nope, it's not even soldered. Did you see me just move it there? Oh, man. All right, all right, all right. All right, we could do this. We could do this. Just need to be careful about it. I mean, the thing that I could do is flip it over and solder it that way. That's always an option. Wait, now it won't move? What's going on here? Oh, it's just held in by flux. I'm glad I'm not doing this. Yeah, you know, it's a bit of a skill challenge. I'm always up for one of those. Okay, please let go of the tweezers. Okay. I'm telling my body to move in a particular way, and it's not. I'm getting like crossed signals here. All right, it just stuck to the tweezers. Are you kidding me? All right, yeah, I think I'm gonna have to dead bug this because I don't think this is gonna go down as cleanly as I'd like it to. Dead bugging is when you solder a component upside down, basically on its face, and that way you are making direct contact from line to line, basically. In this case, the purpose of dead bugging is just because I don't know if I can get those to solder properly by just dropping them down onto the thing. I got it to work here, but I also had a pretty good layout of all of everything. You know, I knew where everything was going to go. So, but the problem is, in this case, this is the gate pin. This is the pin that we need to control right here. So I can't just do like a line to there. I mean, I guess I could do it up here and then, well, hold on. This is the gate pin. That's the gate. Those are the ones that go to the motor. That's the one that goes to the motor. Those to there. Power input on that. This sucks. This sucks. This is tough. Put it like over here. That's the control. Get that over to there. Those to there. That to there. Honestly, like, come on. I gotta be, I'm better than this. Let's go back to trying to solder it this way. I'm gonna see if I can get this to work. I'm gonna twist this whole thing. I'm not straight up not having a good time with this. You know, it's easier. Games. Playing games is easier. Sometimes the game doesn't work, but like generally, you don't have to deal with weird spatial anomalies. Or maybe you do, because maybe that's the game you've installed. How far did Lou get on the tech tree for Factorio? He's just applied for a job. Feels like my day's work is done. Yeah, some people apply to like 20 jobs in a day, right? You got to do that thing where they ask you like to upload your resume, and then you do, and they're like, yeah, so now give us all the information that was on your resume. Good luck to the job hunt, Hayes. It's a tough market out there, right? Jesus, Chester. Applied for 150 jobs in the last 6 months. 0 interviews. Good Lord. Yeah, shit ain't easy out there, right? Well, at least they're not asking for like, you know, more years of experience in a programming language than the programming language has existed. You see that a lot these days. I think that actually made contact. I think I actually got that right. I mean, it's boy, oh boy, is it a mess. This board is a mess. It's a complete mess. It's like my life. It's just in shambles. But it might actually work out. So I need to get rid of the pull downs on both of these, and then we'll use this one and this one in order to control the motor, and we'll just see how that goes. So let's get these resistors out of here, and then we can get to punching the breadboard a little bit. Oh, and then I need to find 4.7 off ceramic caps. Yeah, 10 years in Swift. Why? Okay. That solders, and then this just laughs at me. It's just laughing at me. Someone posted that on Twitter. They wanted 5 years in experience with the creator. The language made it 3 years ago. Yeah. It's a big racket, these job listings. I mean, you know, I hate to parrot stuff that I hated to hear when I was on the job hunt, but it is who you know. It is who you know. That's pretty much like every great job that I've gotten was a who you know kind of thing. Even if it's just like a cocktail party with like somebody else's like work friends or something, you know, every now and then those contacts trickle down. Those have been the best opportunities that I've had. The reason that I got the IED thing was because of a classmate's parent worked there. Not at that specific thing, but at the parent company, which, you know, hey, that helped me get my foot in the door. All right, so we need 4.7 UFs on this, right? God, these things are so small. These are even smaller. These are the gate drivers, and I can't even see them. Ugh. Okay, they're so tiny. Let's find a 4.7 UF cap that I can put into this thing. What the hell is that terminology? I've never heard that before. Purple squirrels? Am I allowed to say that on Twitch? What is that? All right, so I should have a collection of caps somewhere around here. Those are resistors. I think I found the little bin of caps. It was while I was searching through stuff. Where did I go? Where'd he go? We've got a lot of sets of connectors. Nope. 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 There. Found him. All right. 4.7. 0.47. 4.7. 475. Should have known that. I should have known that. 475. That would be these. These are ceramic, so I don't have to worry about the polarity of them. I can just chuck these things in. Purple squirrels are when you make an insane job posting. Oh, that would require the rarest of people. I see. Yeah. I mean, sometimes it's they're trying to hire like internally, and so they have to make the public listing, and so they'll make the public listing like impossible. What's up, Flatulent? We had a raid from Louis earlier, which is pretty cool. All right, so let's get these 4.7s in there. Where the hell do they go? Let's take a look. I don't know where they go. They're ridiculous. Let's see. So we're looking at this data sheet over here, and this data sheet's telling us how to use these parts that I bought, the Mic 5019. And the Mic 5019 is absolutely tiny. This is actually the chip that comes with the COVID vaccine when you get it. That's the size of it. It's that big, just, you know, under your skin, and it's highly magnetic. No, it's just a high side. It's just a FET driver. This thing just makes sure to spark off your FETs to make sure that they're conducting properly when they actually do conduct. And pin 1 is where I've put the scratch on the board. Let me put this back down. Pin 1 is a little scratch on the board. So those are the pin 1s. Accordion to the pin out. Ba, 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 ba. 1, 2, 3, 4. All right, let's do it. So 1, 2, 3, 4. And between pin 1 and pin 2, glucometer just beeped at me. What do you want? I'm back on that med that almost put me in the hospital last week, basically. I'm back on that med. People may go, well, why would you do such a thing? Well, because I've been on it for years, and it only almost put me in the hospital. It didn't actually, and so I'm back on it again, and my glucose levels are now perfect once again. But of course, this happens not 1 week before my endocrinologist appointment. Why is it always the sabotage happens right as you're going to the doctor? I don't understand. Anyway, 4.7 off between pin 1 and ground, which happens to be pin 2. So between pin 1 and pin 2, so from the arrow pin to the pin just below it. Easy peasy lemon squeezy. I gotta make sure that the arrow is facing the right direction, I guess. But there is text on it. The text is giving us at least the Sacred Jedi texts. Yeah, you can't ruin an A1C in 1 week. That's not, I mean, maybe you can. Maybe somebody will take that as a challenge accepted. Because every fucking time I try to say something, the whole chat tries to bring up a counterexample. Actually. But no, in this case, yeah, you can't really ruin an A1C that quickly, so... I mean, your levels just prior to getting the blood test can contribute, I think, a little bit, but not much. Anyway, there's the arrow, if you guys couldn't see that. There and there is where I need to put the 4.7 oof cap. So I'm hoping that I can just sneak this puppy in right here. This one's a little bit more of a problem because of these vias. I don't know where they go. This isn't really meant for this, right? This is actually this little board is actually more for connecting this kind of stuff, right? So those two pins are going in weird spots. So I got to avoid those when I put that cap on there. These 4.7s are huge. These are kind of big. Kind of a big deal. But I can do this. I can get these in here. Technically, what would those be between? Well, it doesn't matter. I just need to make sure that they stay soldered as well. That was the other thing, is keeping the driver chips soldered. Where am I putting this one? Put it in the trough for now, but I'll regret that. Nope. Yep. How am I positioning myself? Okay, I'm trying to figure out where my hands are going right now. Vsauce, Michael here. Where are your hands? All right, this is not ideal. Try it though. These aren't exactly meant as breakout boards for this specific part, but I should be able to operate with them. Might need to add solder to that so that it bridges that. Because yeah, without it wicking up onto that, it's not holding on to it for me. So I'll give a little bit of solder here, although I don't like it. These no lead packages are they're a little bit finicky. And if I had a through hole component, I guess I could probably put that in there to try to, you know, instead of busying up this board. Oops, man, that was a flyby. Well, I hope, oh geez, I gotta be careful. I hope that makes contact to the positive and negative voltage pins. I sure as hell can't tell. Oh my God. What a pain in the butt. Really relying on my, my beautiful workmanship to carry this thing through. I guess I probably could have tried to find a slightly different one of these breakout boards. There are different versions of these that might have some pins that are closer together. I'm a little concerned about those vias sitting right there. If I can get this one to float in like the other one did, should be in good luck. Good shape, rather. Good luck. Well, it is avoiding it. This is where I cough and everything goes psycho and breaks. Everything just flies off in a direction. Really was thinking about whether or not I wanted to actually deadbug these though. It would have been more guaranteed of a connection, like that upper left-hand corner or upper right corner I'm a little concerned with. I think that's making connection, but boy, it doesn't look like it is. I don't know, we'll give it a shot. I mean, if nothing works, then fine, but this should be all ready to go. We should be ready to go with this now. So what I need to do is hook it up. So I need to recall, pull up basically the pinout, because we need this to go forwards only. That's all I really need out of it. So we're going to need the motor. Check. We'll move this board up here. We'll do it upwards, going down towards the motor. So we'll put that there. We'll put this here, and we'll run that, because it's like in-out is the way that these things go. In's on one side, out's on the other. I could just put this here as like a go-between, and then that'll go from here to here to here to the motor. I made a purple squirrel button to wear, complete with googly eyes. That's great. Hello, yes, I am a purple squirrel. And they're like, what the fuck does that mean? You're like, never mind. Okay, yeah. So what's my motivation here? What is my pinout? Well, this is the faithful to the design schematic. So I need to come over here and I need to figure out which ones are forward. Ah, great. I didn't label any of it. Damn it. The software will tell me. Arduino.cc. Set me free. The software knows which way is forwards, I guess. I'm gonna cough. Bah. Where did Arduino go? It's still loading. There it is. Specific code, 8 megahertz, blah, 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 blah. Yes, okay. Forward, pin 2. So yeah, pin 2, forwards. I don't need this diagram now. I don't need the diagram. Pin 2 is forward, okay. Pin 2, and then we need the forward end channel, which is going to be... Oh, well, yeah, maybe we do need the diagram again. 2, forward end channel, this guy right here. This is the forward P channel, which would make this the forward end channel over here, which is pin 6. 2 and 6. 2 and 6. So pin 2. And pin 6. So these two. All right, so let's take a look here. I guess we'll do the microscope because that's easier for you guys to see. Well, it's still not far enough away. I need like something in between these two. Maybe we'll just go close up with the spring arm. That should probably be good. Okay, 2 and 6. So pin 2 would be the high side driver. And we'll just take that over to here. And I need to look at the pinout for these things to make sure that I'm connecting that correctly. I don't need such a large line there. I'm going to reuse some of the ones that I've already used. The wires, that is. Because then this one here goes to pin 6 there. Okay. This one I need a shorter wire for. Yeah, let's take a look at what this means. What does it mean? The one next to ground is in or out? That's my question. Pin 3, 1, 2. Wow, how does it do it again? Ah, Jesus Christ. These pinouts are going to be the death of me. That's what's going to happen here. Because they don't, in their little schematic here, they have in here and out there. That's not 1, 3, 4, 2. What is that? 1, 4, 3, 2. They swap it around for their schematic. Why do they do that? It's so annoying. Why are you doing it that way? God. All right, so 1, 2. In is on the ground side. All right, that helps. Good, good, good. Because I've got power over here, ground over here. In is over here, out is over here. Works. That works exceptionally. All right, good. So we got that right. Let's get ground and power to this thing. So over here are grounds. Ground. G-rounds. Man, I want to play Factorio now. See Louis playing it. I'm like, damn it. Problem is I won't stop. That's the problem with Factorio. You only start playing Factorio. There's no stop. You have 25 12-hour streams later. You wonder where your life has gone. And then you realize that you haven't shored up the south wall, and you got to go do that. Probably don't need, well, I guess I'll keep the orange line on that, although I don't like it. And then over here I've got power on the same side as that. Gotta make sure that I'm not accidentally doing a little parallax there. So power, another power. Power. And then pin 2 is the high side driver. Yeah, I don't need lines that are this long, huh? This is our new high side driver. And so that goes to the gate, which is like right next to it. Hold on. The gate is which one? The gate is this one. Ugh, just need to be a little longer. these mid-size jumpers that these jumper kits don't come with. Let me get the jumper kit out. There it is. All right, jumper. We're probably going to run into all kinds of problems once I get this fired up. I mean, there's probably going to be like a short of some type, or, you know, a bad connection or something like that. I mean, it's just, we're playing a little fast and loose with it right now. The assembly of the daughter boards was a little fast and loose. So that would be that pin right there. I just want to get it hooked up correctly. So I know it's not my perf board, breadboard skills rather. Motor. Oh, somebody subbed. kolejynpodatek. Let's put you up on the board. I already hear it moving, so it placed it very quickly. Oh, Dieter66, thanks for the follow. Appreciate that, man. So yeah, Thursday we're going to work on the streaming computer. So it'll be more 3D modeling and measuring and stuff, figuring out where things go. Finally, I should only need like a day or two on that thing to start 3D printing parts and getting that ready to go. Regards from Poland. Well, hello from Philly. Thank you so much for the 5 months. I really do appreciate it. 5 months takes me a long way, man. Keeps things rolling around here, right? Thank you so much for that sub. Amadeus 5th. Thanks for the follow. Bob. Okay, so yeah, I'm just trying to get this all hooked up to the perf board correctly so that I don't have to worry about that going wrong. So yeah, let me continue on that journey. So if we are powering this one as our high side, the one sitting opposite it is going to be our low side. So that's there, that's there. I haven't given this power or anything yet. I do need to hook up the lines to the motors and stuff. Oh boy, this is all kinds of a mess, this circuit. As we're in like late game test circuit here. So yeah, let me just work through this piece by piece, end to end, basically. So what we've got is our low side driver that needs to go to the low side gate. That'll use an orange wire. So low side gate to low side gate. Which one is the gate? The gate is here. Let me think about that for a second here. Hold on. I need to remember which one goes where. Which one goes where? Seems to be used in many things. Also seems when there's a short, it sometimes blows out. That circuit is secondary failure. Yeah, the FETs are a little dodgy. They'll explode. They are a little sensitive. They can be anyway. Used to be able to kill them with static electricity very easily. All right, so on these, oh, okay, all right, get out of my way. On these, what do we got? We got source, gate, source. So this goes to negative. This goes to the gate. So I need that right there going to the gate. The one next to it goes to negative, and then this one over here goes to, man, I should have just made a bunch of, like, this circuit. I could have just built this 4 times, and that would have been a good tester. I'd have made a little 3-pin device that I just put in the line. I didn't have to bunch them all together and make it all stupid like this. All right, anyway. I should have just made a bunch of these. That would have been smart. Could I still... Hold on. I don't even need this here. What am I faffing about with this? What am I doing? If I take this out, we could just use these two. What am I thinking? All right, I'm getting this thing out of here. I'm getting this. I don't trust it. I don't trust it as far as I can throw it. I can throw it pretty far. It's really small. Oh, we don't need a full bridge rectifier here. A full bridge H bridge. I was actually pretty in there. I actually think I might have did good with that, but whatever. We'll just not trust it. Your ears hear and your eyes see, your mind believes. All right, let's put this away. I don't trust it. I don't trust it. I'm just realizing that the FETs that are in there are logically laid out, and I can split them up just as easily to be one side of the H-bridge motor controller. Because I've got the two gates here, and I've got the two gate here, source here, drain, drain. Twitch is being weird. I'm not seeing anything on my bitrate over here, so yeah, it's on Twitch's end. Unfortunately, you guys might have to punch that refresh a couple times. That's same story, different day on Twitch, right? All right, so what I'm gonna do is I'm gonna take this out and I'm gonna flip it around. I'll do it this way, and now we basically just have two FETs that are just hooked up. I should have realized this earlier. I can just do this like this. That's just so much easier. This is so much easier. Okay, so logically, we've got two FETs. One of them is feeding power and the other is feeding ground. So let's get that all configured up into this thing. So these are the power and ground on the drivers, and then we've got our high side and our low side. They're flipped, but whatever. So our high side FET is going to be, I need like green, I guess. I should buy another jumper kit. I think it's about time. I think it's about time. These things are like 14 bucks a pop. It's, you know, you can sit there, you could try to organize your jumper kit. There's a wire stuck in that. Or you can just get another one. You just get another one. Just kick that can down the road. All right. Let me double check. God, I got hose noises outside. So if this is facing me, it means the gates are on the left. So that means that the gate for that one is here. Make sure to get the right pin. It's the base requirement of this kind of stuff. Gates all the way on the left. I should do an FTL stream. FTL's stressful to stream. Got that music in my head now. Double check. Gate on the left, yeah. Source is here and here. So one of these is positive, the other's negative. Well, we know pin 2 is the high side driver that also goes to the LED. So pin 2, high side driver, high side on the right, high side here. This one needs to connect to power. Now this is going to heat up. These wires are not meant to carry this much current. So I don't have any solution for that. It's just going to run hot. It's just going to run hot. I'll be totally jazzed if this thing runs well, but it is going to run hot. I don't know if you guys can tell that my voice is like not what it was earlier. Maybe I'm always a little bit gravelly or something. Wait a minute. The source of the high side driver, it's the drain. God damn it. All right, hold on. Hold up. So the this guy, no, that's, well, I mean, that's basically giving us our hookup diagram. It's this thing up here. So the high side driver, the drain, is what goes to power. Okay. Which the drain in this case is the big pad. So the drain in this case, for this one over here, it's going to be this pin all the way on the right. Okay, so this one goes here. It's that middle pin that goes to the motor. This is like a weird setup. It's not quite what you would expect from your typical H-bridge motor setup, because we're using this driver that says that it can do high side MOSFET, which is not normal, which is, you know, it's also why I'm not explaining myself to each individual question today, because otherwise I'd get nothing done. Drain in this case goes to the motor. This one, source, goes to ground. And the middle pin, no, that's wrong. That's wrong, it's one next to it. This one goes to ground. And then we do need the capacitor across the motor. So I'm going to do capacitor across the motor right here. Actually, let me just take this motor out. We'll just assume that the motor goes here with a cap across it. And then I need a shorter wire that'll just go from one side of the motor terminals to the other. Just put a little bend in it. So that'll be basically like that. How does that do? We're not going to have as much copper there as I would like. Oop, a bunch of parts fell off. Okay, that didn't go in properly. I want to make sure to get good contact. These are indeed going to heat up quite a bit. Go. Then I'll go from here to here, basically. I can use longer ones, or I can do these. Do I have another gray wire? Running out of them. They're starting to break. That'll do. That'll do. So that will go to one terminal. That'll actually plug in. And then this one goes to the other. Okay, I think that's our circuit wired. It's a little sloppy, but that will allow us to just simply control the motor in one direction. We won't even have brakes. We'll just be able to fire the motor up and have it run in one direction. Whew. There's a lot of stuff on the breadboard that I'm not using. We're basically relegated to one area of it. It's about time that I should probably think about organizing it again, rebuilding everything on it, just because it's getting a little out of control. Power. So the question is, the big question is, did I get everything connected when I did all the soldering for these smaller breadboards? We've got a lot of surface mount parts on here that are quad flat no lead, QFN. QFN means there are no leads sticking out of it. So it's literally just a little box that you are relying on basically surface tension of solder to bridge a connection to. According to the data sheets for the parts that I used, I don't need a lot of the extra accoutrements in order to get these things running. So all I need is a positive or negative signal going into these little guys right here in order to kick on and off these N-channel FETs. What that means is that I've got an absolutely microscopic part with a big capacitor. The capacitor is larger than the part, driving, I got this mess right here, driving two FETs. And so one of them has its two N-channel FETs, which is not what you typically do. N-channel FETs, not what you typically do, but this is the configuration of one of them, and this is the configuration of the other one. So we've got the drain, the gate, and the source here, and then our load sitting below the source, which typically your N channel, negative channel FET, sits like this, with the drain up against the load, the gate on the gate, of course, and then the source is going down. Wait a minute, no. Yeah, source is going down into negative, right? So drain, gate, source, like that, yeah. So let's check that over. So look at that view. So we've got on this thing here with the pin, with the thing facing towards me, right? So the big pad is back here. The big pad is the drain. So drain and drain. One of the drains is connected to the motor. That would be this one here. That'd be the low side one, connected to the motor. That goes through the capacitor, but it's also connected around to the other motor terminal over here. Motor, of course, has this little 0.1 UF cap on it to keep it from being noisy. And then the source of the other one, these pins right here that don't even look soldered, are connected to the other side of the motor. Good. Okay. Okay. Which means gate and gate, these two pins here, go to our drivers on the outputs here. Ground is opposite of the input, right over here. Gabriel Berry, thank you for following. And then the inputs are here and here, going over to here. We know pin 2 fashions itself as the high side driver, which I plugged in wrong. This is why we do the double check. Pin 2, high side driver, coming out here, coming in hot, all the way over here to the right. High side driver output goes to the gate of this one, fashioning itself as the high side driver, which means that the drain is connected to positive power, and then the source is connected to the motor. Okay, I think we're ready to go. Can't watch Twitch, it's being twitchy. Ah, that sucks, dude. That's always tough. Tough titties when Twitch won't cooperate. All right, so my hope is that everything is soldered correctly and that when I run this, the motor will run perfectly fine the first time out. Now I've bussed power to everything. I need jumpers for power. Let's get some jumpers. So we need positive power on, I guess we'll do it on yellow. I don't want to involve the scope today. I don't think we need it. So red to yellow. This is going to be 4 volts. Positive right there. Negative nearby. And then I need the remote. I need the controller. Because we do have this hooked up. This is basically, we've got the receiver right here. Then we have, this is the old controller that we based this off of. This is the new controller, the ATtiny85. We've got LEDs to give us status indicators, and then the rest of our test circuit over here. This is just an extra set of MOSFETs. These are actually CMOS compatible. Should have thought about that. But they're too big. They're too big for the design. I probably could use these if I could source them. But yeah. So controller. Turn this puppy on. So I'm going to hit the power button over here. Power supply is going to boot up. I'm going to put that drawer away. I don't know what that's doing over there. Why is that drawer still out? What was even in there? It's like some weird screwdrivers and stuff. We're at 4 volts. 4 volts and an available 10 amps. We also have to remember that when we use the battery, everything gets a little bit more stable too. So if we get a little bit, excuse me, a little bit of throttle instability, like when I go to high throttle, that might be because the power supply can't quite supply power properly. Why is it solid red? Okay, turn it back off because that scares me. What happened? Anything get hot? Nothing got hot. Why was it solid red? Solid red. Why were you solid red? There's no reason that should have been solid red. Unless it interpreted braking, B-R-A-K-E. These lines also break periodically over on this side. That looks all right. Okay. Looks all connected. That looks all connected. Let's try it again. Power is definitely the power. Ground is definitely the ground. Try it again. Oh, there it goes. Well, works. Now, it doesn't strike me as hitting the high speeds like it did before. Of course, I don't have any brakes or anything like that, but do some partial throttle. The motor's working, so my circuit worked. I didn't expect that to happen. Not that much heat going in through the FETs though. That's nice. So yeah, end channel drivers work. That's pretty cool. I'm just gunning throttle around to try to test it out. Now, how do I make a determination about whether or not we're actually hitting the full throttle that we can hit? It doesn't feel like it's totally being released. Now, this thing is under 4 volts, 3.99. If I go to DC volts on this and measure across the motor, maybe I'll get something. Not like I have a ton of spaces here. Well, that's pretty much full voltage. Oh, that's cool. So last time we did this, and I'd have to pull up the VOD in order to see this, we got something like 3.5 or something, right? Wouldn't it a lot less than this? Whereas here, we're almost getting full power. Oh, I'm on board for this thing then. That means we can go forward with the design. All gas, no brakes. That's right. All brakes, no brakes. Yeah, I'm happy. This is good. All right, so FET drivers, huh? I mean, I know I give Chad a lot of crap for stuff. Yeah, it was lower than 3.4. Yeah, so we were definitely losing out. Whereas this is able to, and this is actually able to handle low throttle better too. Oh yeah. Oh yeah, I can feel that. I'm just like gunning it. All right, we're in business, folks. This is good. So I didn't expect this to work at all, by the way, guys. I played it kind of a little too easy with these drivers. I didn't double check my work by ohming it out at all. We double checked the circuit to make sure that the circuit was still doing the right stuff. You know, all the right stuff was plugged in faithfully. I expected that some of our monkeying around with this part of the FET would have unseated some of the connections in there. None of that occurred. Now, we're not testing forward, reverse, braking, and noise. It seems like we don't have that noise problem anymore. Then again, I can't put it into braking and stuff, so I don't know. But I don't think we're going to need to add diodes to these. I don't think we're going to need to add diodes. When we added diodes, we got less voltage out of the motor. In addition to the fact that we now have the FET drivers that are definitely kicking these things off. In terms of noise getting back into the rest of the system, I don't know. So it's a little bit of a leap of faith. I mean, I could try to hook up 2 more of these end channels and get that whole circuit running so that I can gun it in forwards and reverse to see if we can get any noise to go back into the system, but I don't think that's going to be the case. I think maybe these things are doing a bit of a job doing all that filtering. Maybe. The other thing is we're not seeing any heat up on the lines, but I think if let's give it a current test. Let's give it a little bit more current. Let's give it the beans. Let's see what it does with the beans. So this is a much more powerful motor, and the reason that it's more powerful is because it's got much larger windings. And the larger windings will make it go psycho. And it'll heat up all of the wires that you see in front of you. Huh, or not. Hey, I can start to see the traces heat up. Oh, it rebooted itself. Son of the bitch. Yep, we're back in noise territory. Yeah, if I gun it, it dies. All right. Well, here we are again. I can kind of sneak it on. No, I can't. Wow. What is causing that? What the heck? Yeah, it draws just enough and it kills it. If I provide power elsewhere, will it survive better? Nope, I don't think that's the case. Nah, these are, it's significantly slower because it's further away. Yeah, it is running better. It's just the increased amount of copper between stuff is affecting it. What's getting warm over here? Is that just the one FET? Yeah, the one FET's getting a little toasty. Not hot, it's just warm. Yeah, I've already got 2 caps on the AT Tiny, but if I wanted to compromise here, I would probably, let's see. Power here. Well, it takes it a bit to get forward locomotion. Yeah, it's not failing when the power's over here. I guess the power for the motor gets really dirty. So if I do the Schottky diode, that would filter it out. If I put the power connector on this side of the motor driver, see what happens there. We get much better performance. Oh yeah, so there's no noise now. Of course, I don't have brakes or anything like that, so I can't like induce noise. But before, on partial throttle, it was powering itself off. Whereas here, everything is very spry. And I definitely get that full throttle experience. And that was literally just moving the power lines from here, over here on the other side of the motor driver, to here. So now it's branching in 2 different directions. So this branch over here, subject to noise, but the power that comes over here for this thing doesn't have as much noise. So with that little bit of an extra kick to the FETs, we get the full throttle experience out of this thing. Of course, everything's also heating up. But on a circuit board, this would be much, much more reliable because obviously things aren't, the traces will be much shorter. And I'll have to make sure to do a, I'll have to make sure to have, you know, a separate branch for the radio power and stuff. I just hope this thing will be fast enough. I think it will be. I mean, we got it working last time with this motor and everything, and it was actually really, really, really zippy. And then I will have a larger capacitor on it. I will have a big capacitor on it, just to be kind to the rest of the circuit. So I mean, if we want to simulate that, I can just put the smaller of the caps that I have here What are the voltages on these things? 25 volts? Yeah, those will be fine. 330 off. And if I put that in as if I put it into the circuit, that should be here. Just double check. I don't want to blow up another capacitor. As much as I like making live stream fails, noisy, partial throttle. Yeah. All right. Everybody's having trouble with Twitch. Oh, man. I'm filled with so much more confidence than I was before. Oh, wow, this thing's getting warm, huh? Not really that warm. With 2-cell behind this, the 2S battery, this thing would get hot, like legit hot. But I don't want that. I don't want that. If I wanted to go crazy with this, by the way, guys, I probably could just get a 3-phase micro motor for this. They sell 3-phase tiny little motors, and I could go to like 2 or 3 battery cells, and then the motor controller would have all this stuff that we tried to design in it already, all the configuration modes and stuff. I didn't want to punk out and go with a 3-phase setup. Yeah, I don't think it's going to be particularly fast, but again, I can just... oh, wait, it reset itself. What happened there? Oh, stall. We didn't test stall. Ah, it's resetting itself on stall. God damn it. Which means that it probably won't be able to go forward as well. Yep, it can't. It almost can't. God damn it. What is that? What is that, and how do I solve that? Do I need diodes on this thing again? Because it seems like it gets a current spike and then it kills it. It kills it for the rest of everything else. Like if this thing can't provide enough current, it's just a short at that point. How do you make something like this survive a short out? Because like I can't even launch the RC car like this. Oh, you know what? The way that you survive shorts is by not having the voltage drop. That's what it is. Remember? The power supply is not as good at that. It's the battery what excels in this scenario. The battery is good for sustained load, whereas the power supply, the power supply is good for sustained load, and the power supply, I don't know, it does stuff to like switch frequencies and stuff in order to provide all that power. So like this, yeah, this can run into stuff without shorting out. That's more like it. Oh, I also get a lot more power out of the thing. I mean, obviously there's a little bit more than just one cell behind that. In terms of voltage, it's only 3.7, but it's a big parallel battery. That's like a longevity kind of battery, right? That thing's going to last for a long time. I do need to charge it, though. Yeah, this thing will obliterate ankles. All right, cool. All right, so under battery power, it's obviously a lot better. Oh, okay, it just unplugged itself. Jesus. Alrighty, we're in good shape. I think I'm a little bit more confident in this thing now. It's been pretty shit the whole time, but about as good as my college classes were last year. You mean in terms of like getting disconnected and stuff? That's horrible. I haven't been watching Twitch today yet, so all of my early streamers, the ones that I'd watch when I'd wake up at a normal time, they're not doing as much anymore. I'd have some shows that I'd watch in the morning and stuff, catch up on VODs. Immediately after saying that, my stream's been perfect. Kiwi strawberry. So it seems like Kirkland as like the brand, because you know this is like no carb sparkling water with flavor in it. it seems like they like took a page out of everybody's complaints about LaCroix and they went in completely in the opposite direction. So these are like over flavored. It's ridiculous. I don't know, man. They're okay, but I just feel like I'm drinking chemicals when I'm having these. It doesn't help that this thing is like toxic green. Like Toxic Avenger color over here. It's like gack. All right, so that means that I can put this part into my design, which means I need a 3D model for the part. Now this thing is super simple though. It looks like my pool water. What have you been doing with your pool? It is literally the color of gack. It's Nickelodeon slime. Oh man, sorry about the cough, guys. I don't know how long I'm gonna go today, just because my throat is kind of feeling it. Algae infestation. I could get a scrubber in here. I mean, this is like, yeah, that's algae. That's an algae. That's. I'm drinking algae today. There's a lot of organic compounds in the. I've already got these things modeled in the computer. However, we need our little driver, our little high side driver, the thing that's doing all that cool work for us. That's actually fairly easy to do, and I guess I can walk you guys through the process here. It wants to update all of my libraries here. So what I'm going to do is I'm going to go as if I'll add a new part. I'm just going to put a new part down. Do I need to base it on another part? I don't think so. Add a new part. And typically I'd be going into components, my managed components library. But that part isn't in here. I already know it's not. So I need to open the library manager because I can't find the thing that I need. Now, another quick question is whether or not DigiKey already has the part. Well, they'll have the model for the part. That typically doesn't really work all that well, especially with a part as generic as these things. These things are just little squares with 4 pins on them. I mean, I don't really need to worry about it. Mic 5019. So MIC 5019. And I'll just go directly to the DigiKey. That's microchip. That's microchip. That's not what they look like. There's no pad on the middle, huh? DigiKey.com. Why did I search it? Nah, whatever. Mike 5019. Put something called the algae kill, yeah. Gate driver, high side, QFN. Look at this little bastard. It's just a box. I'm not going to get, I mean, it's not like there would be Eagle resources for this. They do have a CAD model for it, but it's like, do I really, like, watch, this will probably want me to sign up for another service, right? I'm so sick of having to sign up for everything. This is Ultra Librarian. Is this any good? I need to make a login for it. There's like a couple sites, and DigiKey's been relying on some of these sites, multiple different sites, and I'm so sick of having to sign up for logins for everything. Hold on one sec. Ultra Librarian is very nice. I don't know. It's a box. It's a box. Come on, we can make this. We can make this in the software. I don't need all that. All right, so I need to edit my managed. Well, I have chips manage and components. I think this is more of a component. Because I can't edit it from here. All right, so let's open the library manager. I thought I could just do it in place, but it's not being cooperative. How do I do this again? I can open it through here, or let's see. Yeah, Bug Me Not would probably also have a login for it. Oh, I didn't pull chips managed into this. Okay, I see. So, available. I need to go through and like really organize these. These need a lot of help. Did you get the keyboard repaired? Yeah, it doesn't, I don't know, some of the keys are fucking with me a little bit. I need to make a list of the keys that I need to pull to take a look at them. I think what happened was when the alcohol dried, I think it dried all the way into where that little tab makes the contact to the key. And I think it dried all the way into that area. And so it probably, as the alcohol dried away, all the sediment concentrated into that little area of contact. And so some of my keys don't initially work as well as they should. Like the 8 key is really important to me, and the 8 key I just keep hitting, and it doesn't work again and again and again. And then finally it'll start working again. I have to like break in my keyboard every day. I hate it. I hate doing that. So I think what I need to do is pull the key, open it up again. Maybe I'll have to 3D print that key puller, open it up again, and then just like wipe the 2 metal contacts a little bit. Maybe even get a little piece of sandpaper on it. Just go shoot, 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 and just open it up a little bit so that it actually makes, automated keyboard exerciser. I'll have to have something that comes in and just punches the key 100 times. That's what I thought would open it up. But I mean, if you look at the way that that keyboard works, there's the contact and then a big piece of, coated copper behind it as a spring. And when the key is in place, they're separated. And when it's pushed down, they spring against one another. And so with the thing disassembled, they were all pressed against one another and then bathed in alcohol for a little while. And then I put them out and had them dry. It would be far easier to order some switches. I'm working with what I have. I didn't want to spend another $75 on that keyboard. I don't want other keys. I like my MX Clears, and those, I put some work into them. The keys that work very well now. I mean, it was a full refurbish. There's just, I should have done another extra step before allowing the keyboard to go back together, which was dry the contacts and maybe just give it a little buff. But that's it. I just needed one extra step in there to ensure that all my keys worked properly. Yeah, Shorty had one where it was like the switches, they were all in sockets. You could just pull them. All right, so I need to make a part, and usually once you get into it, it's easy. I just need to remember what my kickoff is on this thing. This is the one part of Eagle that I really think needs heavy revision. I need a better library manager. This is like working with like MMD models. It's just so convoluted. So my managed chips, I'm going to use that. And then I think now that I've got it used, I can actually edit it on the In Use tab. There we go, edit. Archer64, thanks for the follow. Same with Rich Handler. And Shark Claw Mex. And Gabriel Berry. I appreciate the follows, guys. We're just kind of noodling around today. Why are you up? You're not supposed to be here. Get out of here. I don't need that. All right, so what we're doing is we're creating a new device. All right? So plus, and then this one has all the symbols behind it. So new device name. So this would be the, what are the other ones called? ATtiny, MLX80. Okay, so we'll just do a part number. And like I said, this is the one part of Eagle that I really dislike because I think it could very much use a revision to it. It doesn't flow properly. It's not as, you'll find that it's the structure of it is a little strange. It's sort of like patchworks on patchworks. It needs more of a unified structure that I can get into and edit the individual parts without some of the weird stuff happening. So we're going to be struggling a little bit to do this, but hopefully I can take us through it well enough that you guys can get an idea of how to do this. So Mike 5019 YFTTR. Okay, control copy. I'm just going to put that straight in there. That's what we're doing. Okay, good. Now, you can sometimes just import this stuff from other places, but so far we have nothing. And this inspector thing is insistent on taking up 3/4 of the screen space that we have available to us. All right, so we got nothing. Good day to you, sir. So we need a new symbol for this part. Now, typically I will take a symbol from another part and use it. In this case, I think I can get away with drawing my own. I just hope it's sort of to the scale and quality that everything else is. It would be nice if I could pull up an example that I can follow, but how's the bridge going? I think these things fixed our problems, the part that I'm trying to put in right now. So yeah, anyway, I'm going to create a schematic symbol for this thing. So Mike 5019, click OK on that. Okay, so we have a schematic drawing here with nothing. Nothing but the inescapable void of our own thoughts, right? So what I'd like to do is draw a box, which is, you know, the bread and butter of AutoCAD. Unfortunately, we don't get all this wonderful, we don't get to quite use the same tools as we typically do in AutoCAD. Oh, that's a filled box? Come on, man. So, yeah, we're going to start on the symbols layer, I think. Pins, buses, values, patch top, v-score, we're not worried about that. Modules, nets, buses. Yeah, I think we do start there. See, the problem is I don't have an example open, so I can't get this all exactly right. I may have to open up a different part in order to vet this out, get all the fonts correct and stuff like that. But anyway, I'll just start off with a box. Start with a box. Anchoring it to the lower left-hand corner, maybe that's not a great idea. I might want to anchor it somewhere that's going to match with the rest of the schematic so that I can actually drop it down on top of another signal. Sometimes they'll do it in the middle of the part. If that doesn't line up properly, it can cause a lot of annoyances. We know there's 4 pins on this thing, so I'm just going to grab the pin tool. So that's easy enough. And then we can give them different functions, different lengths, different displays. I'm just going to go with the stock pin. And I believe, yeah, we go out. So there's 4 pins to this device. So I'm probably going to have to change the size of it, but I'll just do 1, 2, flip it around by right-clicking, 3 and 4. So it's pin 1 through 4. Now I can make this a little bit more even and look a little bit better. Just bring that in, bring that in. That should be pretty good. Let's see. What else do we need in this? I'm using 4 of these to drive all of the MOSFETs, as detailed in the datasheet. So let's see. We need text for the name and the value, right? This is where I should probably look at an example of one of these things, right? Because there's all kinds of other things that I need to worry about for this specific part, getting like the name and the value and stuff. Because for instance, on the names layer, I don't think I do name. I think I do like U4 or something like that, or I gotta look up an example. I can't remember how to do this. So let's save this. Mike 5019 will come back to. Yeah, see that? So we do name and value like that. Caret name, caret value, and then we can name the pins and stuff like that. All right. See, that just answered all of my questions very easily there. What layer are they putting this stuff on? Is that on a pins layer? Looking for the layer info. Now, what layer are you on? I'm trying to get it right. Nets, buses, pins, symbols, names. I mean, symbols is where we started from, but info is probably no. Yeah, I'm just trying to figure out how to select this. I could always just turn off the layer until they disappear. Not pins, not symbols. Okay, so it's all in the names layer. That's what I was looking for. Boy, see what I'm talking about with this thing being a little bit convoluted? Okay, cool. We will copy that. And actually, that means I can probably tighten this up too. Oh wait, where were the pins? Pin names were on info. Okay. See, there's little details. There's little details. So I want to put text on the info layer. I don't remember the font size. Oh God. All right, we'll do all this first, and then we'll get there. So info, boop, not values. Info, 1, 2. Three. Now I have a choice here. I could make this go 1, 2, 3, 4 like normal. Or I can do it like they do in the schematic symbols. I'm tempted to do it like they do on the datasheet. So in this case, the way that they're ordering them is 1, 3, 4, 2. It's weird, but that's the way they're doing it. I think they wanted to have a right to left flow with the symbol, which it's a little weird the way that they did it. Doing them all on one side would have been probably okay because you could have run a line in and had it come up and then back. But going up and back on a schematic is generally discouraged. You want to be reading from the upper left to the lower right. It's sort of like, you know, reading runes. In this case, what they decided to do was the pin order is 1, 3, 4, 2 because VDD is on the left, that goes up, ground is on the right, that goes down, and then your schematic flow can come in from the left and go out to the right. So we'll do that. So yeah, let's 1, 3, 4, 2. Okay, I didn't want to put that. Can we? Okay, all right. There we go. I wasn't clicked into the window. So 1, 3, 4, and then 2. Oof, that lag when picking stuff up. And then, where is this stuff? I guess that's dropped in on the names layer, right? So let's go to names. They don't give me a spot to grab it. I prefer the down on the left side and up on the right side. Is that like TTL standard? I'm not sure. Yeah, that's a different standard. Edit text. I love that it doesn't let me do anything. I guess that's part of the pin, isn't it? Yeah, name P1. So 1 would be VDD. 2 would be GND. 3 would be, what do they call it in the data sheet? Just in and out. Okay. In. What I'm doing is I'm right-clicking on the pin and going to properties, and that's editing the whole pin. So it's not just $$3. The $sign also denotes a number that can be incremented if something changes. But we don't need to worry about that right now. So in this case, $3 is just going to become out. Oot. Now, I'm wondering if I can make that a little smaller. Because, I mean, if we look at, I'm going to save that, go over here. Those are looking to be about the same density as what we already have. It's hard to tell just because of the size difference between these two. Everything is on a very strict grid when it comes to making the schematic symbols. Yeah, I guess we can make it a little bit more compact. Oops, that's this. I mean, I don't need it to be super small, but it should just not be wasting space. Good enough? I think that's good enough. These are a little bit floaty, but I can't do anything about that. So, let's see. Names layer. This would be name as a lowercase. Damn it. I want to get this right, because otherwise it won't replace it properly. Name value. Okay. And then we go to the values layer, not info, values. I don't think I need to do that, but I'll do it anyway. That's a little sloppy. But that's too close. I can do the alt spacing, I guess. Yeah, we'll have to do the alt spacing. I'll just pull these in a little bit too. Hopefully this doesn't look too jarring against everything else in the schematic. There you go. All right, so there's our Micrel MIC 5019. Hey, Camara, how you doing? Control S. User saved. All right. So we have a schematic drawing of this thing. Well, that's one step. It's one step of the way. The next thing we need to do is actually create a footprint and a package for this. Now, I would like to use... Well, let's go back to the... we need to go back to the full device view. Yeah, there's no symbol associated with it because I created it out of nothing. All right, new... How do I get the symbol on there? Let's see. Go. And then I guess I'll just put it like that. Okay, so there's our symbol. It's a little awkward there. So, new package, local or from web. So the web interface is just about the same as the local interface for creating a three-dimensional part with a footprint. But the web interface, I think, does it a little bit better. They're very similar to one another. They're pretty much the same process, only one is local to Fusion and the other one exists in library.io. Library.io is a decent amount of tools though. So we're going to add from web. Oop. And that's going to like automatically log me in and do all that stuff. Now I can choose from all kinds of stuff that I've created in the past or stuff that exists, I don't know, on the web or some shit like that. I don't know. My library of three-dimensional parts is not as extensive as I would like it to be. I really should get into editing it. But what I'm going to do here is not listen to Fatanon, who's giving me answers that I already know the answer to. I'm going to create a new package, even though the package already exists and it's a fairly well-known kind of thing. All right, I need to sign in. There it is. Just give me one sec. I got to log into AutoCAD so that I can verify that I'm me. Okay, it didn't need me to do the 2FA. Okay, so what we've got here is the online package editor. It's a pretty powerful interface for what it is. I mean, there's, so like, you know, putting together here, let me, chat is on that window, so I need to orphan this. Here we go. Pull that over here. I don't need your stinking answers. I already know what I'm doing. All right, so what we need to do is we need to make a new package, and this thing isn't unique. It's like a lot of other parts out there, right? It's a square, and it's got pins on it. That's not that difficult to do, right? A square with pins, how hard can it be? Well, it turns out a lot of these packages are, man, I gotta get a haircut. I'm all hair. Anyway, so yeah, a lot of these things exist in sort of a, how do you put it? I wanna say algorithmic, but I don't think that's the right way to put it. But the approach to creating these parts is fairly samey for a lot of the different parts that exist in those package types. So all we really need to do is identify what exactly this thing is or passes as, and put all of our different stats into this thing. I mean, DFN is very close to what this is. Technically, the datasheet should probably give us some kind of package name, but it really is up to the manufacturer to come up with whatever the hell package they want to describe it as. They just make up stuff after a certain amount of time. So the mic 5119 is available in an ultra small 4-pin 1.2 by 1.2 thin QFN package. So quad flat no lead, I guess, is what they're calling it. The question is, if we do a quad flat no lead package in here, is it going to break the software? We'll have to find out. So here's our interface for making a QFN chip. These QFN chips, they all kind of follow the same rules, right? Typically. So all we need to do is punch in the numbers, and this should give us the appropriate package. But I don't know how much I trust this, because it really doesn't strike me as a QFN. This thing it's barely got pins. Like, look at this. That doesn't make no sense. I don't know. I feel like I should define it as like a crystal. But I don't know. We'll give it a shot. We'll give it a shot and see what happens. So let's go all the way down to the mechanical properties of this thing, which are, oh God, they're like a terrible drawing. Usually what you'll get is different. Oh man, this sucks. All right, usually what you'll get for the package outline is you'll get different, like, you get like a table of values. That table of values takes on a specific form with capital D and lowercase d and stuff like that you can transfer from one to the other. Usually from here to the online package maker. For instance, these guys, these Vishay Power Pack SC70 6Ls are a weird package, but this exists inside of the 3D package creator. That actually is not that unique. That exists in there. And so I can put in all these different numbers and it'll poop out something that approximates the chip properly. I don't know if we can do that with this. This is like barely a chip. This is weird. So let's I don't know. Let's give it a try as I drink my algae and radioactive waste. God, it's like being punched by a kiwi. Ugh. Ah. Not like a New Zealander. I mean like an actual like kiwi fruit. It's like it reels up and it just socks you in the mouth. Number of pins. 4. Oh, number of pins on the D and the E side. Is it 1? It might be 1. 1 and 1. Rectangle. Density level. Nah, we'll do nominal. It's like a kiwi bird. I'm just mentioning kiwi bird. It's like a kiwi bird rolls up and punches you with a kiwi fruit in New Zealand. All right, so E. E is the distance between the pins. Does E apply when I do one pin? This is gonna break. This is gonna break everything. Just because the statistics that I have to give it. 0.65. Is that inches? Is that millimeters? It's millimeters. Yeah, it's weird. I don't know if maybe they expect you to have. These are weird pins. They're very strange pins. Maybe it is 2 per side. Let's do that then. But they're not gonna conflict with one another. It'll think there's 8 pins if I do 2 per side. We have 4. I'm gonna do 1 per side. Let's just see what happens. We may need to get creative with this. Yeah, it's like everything I try to do is breaking software, huh? So yeah, what is our E is 0.65. BSC, I don't know what that is. Well, recommended land pattern. This is like, why didn't they make this normal? Okay, 0.65. Oh, pad shape. Yeah, let's keep them rectangle. 0.65 L. Now here we're using their stuff. So, oh God, what the hell is L? L is the pad width. It's the pad width, but it's also the gap there. So L would be 0.49 plus minus 0.02. So 0.47, 0.51. Lowercase b for butts. Lowercase b for butts is the pin width. This is what I've been doing, man. This is what I've been doing with the software. 0.23 plus minus 0.02. Doing all these little calculations and stuff, trying to get the parts to properly represent themselves in the software, in this convoluted fucking thing. I wish I could just go through my list of parts and do all of this editing very quickly in a better interface, and that way I could create all the three-dimensional parts that I would use to create designs. But instead I've had to go through, we're like 6 windows deep into this program right now trying to make this part. I think what I need to do at one point is just sit down with the library manager and just go end to end. Just go end to end and create a brand new library with all my stuff. How's it going, Turts? How you doing? Turts, there was somebody who a friend of a friend brought in to play Vermintide with us, and he sounds exactly like you. I don't think he's even remotely near where you are, but it was weird. I was like, is that Turts? It was weird. B, okay, pin width. 0.23 plus minus 0.2. Well, these numbers are very close, but 0.23, 0.21, 0.25. 21 to 25, lowercase b. Capital D for butts. D is the overall width. That's 1.2. Let's see what their over-under is on that. Plus or minus 0.05. I'm just call it 1.2. 1.2 to 1.2. I'm not going to give that the over-under. Capital E. That's the same thing. 1.2 to 1.2, right? Yep, same numbers. A is the height of the overall chip. 5 miles. Height of the overall chip, 0.550. Jeez. 0.550. It's nice to do this with a keyboard that works. The last time that I did this, you guys, you know that we just did a whole keyboard refurbish, right? So the last time I did this was after I had spilled all that bullshit on the computer keyboard, cleaned it, and thought that I got it working again, and then I started doing this job, and the problem was some of the buttons wouldn't work. And so I'd hit the number and it wouldn't come in, and I'd punch it a bunch of times and it wouldn't come in. I'd hold it and then it would come in 50 times. And I was like, what is going on? Why is there so much lag in the software? It was the keyboard dying. No thermal pad. Map silkscreen to body. We'll go with maximum, sure. I don't know about fabrication and placement tolerances, but let's hit update preview and see what explodes. It's like, no, you can't do that. You can't have 1 pin per side. Watch it be 1 pin in the middle. Oh, I'm gonna get annoyed if it's one pin in the middle, and we need to have some kind of it's 1 pin in the fucking middle. I only realized that when it was too late. It's 1 pin and it's in the middle. Oh no, that's not at all the part. That's not the part. All right. What if I take it 2 per side? That looks more like what they tried to lay out for us. I keep seeing, I thought I saw chat move, but it wasn't chat. Oh, dear God. Oh, dear God. What in the fuck is happening here? Dear Lord. There's, okay. All right. All right. All right. All right. All right. All right. Where did that go wrong? Where did that go wrong? I think our numbers, I think some of our numbers for the, okay, what, okay, can we just, okay, hold on, everybody chill. All right. Something about these numbers is not coming in correctly, so we need to figure out what's going on here. So we'll start with L. L was the first offender here. L, well, actually the pad layout is 1.4. Okay, so L, 0.47 to 0.51. That's determining where the pins go to. And I'm saying there's 2 pins per side because I'm trying to match that like cloverleaf pattern that they've got right here. That's a very strange little layout for this part. I wish I could just put a big pad on each corner, which I guess I could, and then I could have you know, something else render this. But I'd rather just put it into these tools and have it poop out the right thing. I think it has to do with, yeah. So if I measure, okay, so this is the problem, is I was using their suggested land pattern instead of their actual dimensions. See, this is what they want you to lay out, and those were the numbers that I was using because they were just right there. I should have been using these up here. So let's use the numbers up top and see what happens. So the distance between, well, let's start at the top again. E, little e, is the distance between the pads, 0.65. That's still there. Capital L, which is the distance from the edge to the pad. Now is it distance to the edge? Okay. So L comes out here to the ends of the pads, whereas over here, there's this little cutout right here, and then there's also a distance to the edge of the pads, 0.375. So what am I supposed to do here? I could do 0.375 plus minus 0.5, or I could do that little interstitial distance, that little space between pads. Let me do the 0.375. Maybe that's the answer here. So 0.375 minus 0.05, 65432, 0.325. Jeez. 325. Wait, that was the one that I shouldn't touch. No, that is 0.325. And the maximum 75 plus 5. 0.425. 425. So dry. That was L. Yes. Okay. So B is the pin width. In this case, it's 0.2 plus or minus 0.5. So it'd be 0.15 to 0.25. Yes. D and E are the same, 1.2 millimeter for the width of the component itself. Okay. A is the height. That one stays the same. Everything else is good. Update the preview. Let's see what happens. Okay. Oh, nothing happened. Absolutely nothing happened. See, the problem is this is kind of crazy for the layout, having it like this. I wonder if I make the pads nominal, what happens? No, that's not for the pads. That's for the silk screen to body. Maximum, that's imperceivably going to pump that out a little bit. Okay, pad shape, rectangle, density level, most. Nope, most dense, least dense, doesn't make a difference. Why are my pads, it looks like my pads are smaller than the actual pins as they're defined on this thing. Of course, the pins as they're defined on this thing have like a rounded end. That doesn't really matter that much. It's just kind of a weird detail of what it does. The E size, I think I got as correct as I can. 0.65, yeah. Is it that I'm getting, is the L distance different from what I think it is? What if I make L 0.175? Well, it's 175 plus or minus 0.05. So 0.125 to 2.25. No, 0.225. Right? 175, 7, 8, 9, 10, 11, 12. Yeah. Yeah, okay. We'll try that. Oh, it updated it immediately. Dang it. No, you don't need to, well, I guess that worked. I mean, that's almost what I see on this thing. It's just that little cutout is not there. That's actually almost it. I don't know. I feel like I need to take this into CAD and do some measurements on it, though. Yeah, that piece right there, I don't know what's going on with that. And that's determined by L. I mean, what if I just punch in L as the same number? What if I do 175 on both of them? And just not leave it up to the minimum and maximum tolerances, because this is such a weird, it's such a weird part that we're trying to get the software to do something that it's not supposed to. Did that update live and I just hit generate anyway? Why did that take it to 1.8? Well, if that's the inboard distance, then maybe I need to add these two together. Or have I already been given that number? Yeah, 0.375. That's what I was looking at. Yeah. That's 0.375, but that's to the end of the pin there. We could technically think of that as the end of this. It just rounds to 2 decimals? Okay. So 3.7. Yeah, 3.7 overshoots. Why does it updated after I hit the button? Like right after, it was like, I just want to get an idea of what, I mean, I guess I could live with this. This is like not within the printing of the circuit board though. It wouldn't really enjoy this very much. See, the thing is, once I design this package in here, all I have to do is assign the different pins, right? Yeah, it is noise source. It's more like a clock than anything else. It's like they call it a QFN FT, quad flat no lead, but there's only 4 pins, and they decided to do like 2 pins aside is the best that I can deconstruct this. 2 pins aside, and so they collide with one another. Yeah, should I try 0.3? Get rid of the 7. That's a little more in line with what it should look like, yeah. It's weird that it's got that little cut in there, but I guess that's what the manufacturer was doing. I'll have to measure this in CAD to make sure that that's okay. What an odd chip. Why didn't they just give us 2 pins, you know, on one side or something like that? Very, very strange little goober here. But it's small, so I'll have to deal with that. And why did it decide to have such a long lead? I guess that's just what I get to live with. I mean, I could do oblong pads. That's gonna round the edges. Oh, that's actually a little better, isn't it? That actually cuts the corner a little bit nicer. Got a little weirdness in it, but yeah, I do not know. Maybe they did this just for mechanical tolerances, like they wanted it to really anchor down. I think I'm going to stick with oblong pads. That seems to be a little bit more elegant. There's not a whole lot of space to solder onto either. That's going to be really annoying. I'm going to have some fun with that. Editor's note, he would not have fun with that. Assigning these pins is going to be a bit of a challenge, but I'm going to use the bathroom, and then we're going to click the button to put this into my library of parts, and we'll assign pins and do all that fun stuff. But you can see here that the library.io pretty much makes the 3-dimensional part for me now. I can just do that with just about any of these algorithmic style parts, and then I can make my own schematic representation of it. It's a fairly simple workflow. I just wish it was laid out a little bit better. I don't think the software does it the best way possible. What they do is they allow you to make banks of schematic symbols and parts, and then each schematic symbol is assigned to a part, and each schematic symbol in that part can be assigned a footprint and a package, and multiples of that. But it's like, they need to revise the way that this stuff goes together. I would rather, I mean, to be fair, like for me personally, I would rather them all exist as like files in a folder structure or something like that. That would be cooler to me. I'll be right back though. I'm gonna put up BRB and stuff like that, and do a little bio break because I got a radioactive seltzer going through my freaking whole deal over here. How do I do that again? Overlays, BRB. It's been too long between streams, guys. All right, and then you guys can get a little bit more FTL. I'll have to find another game soundtrack that I can use too, but this one is too iconic and too good. I've wanted to listen to it for a while. I'll be right back. There's so much broadcast delay. I opened up Twitch on the other computer and I saw myself get the mic cable. All right, I'm back. Just when the song's getting intense. I'll fade it out. All right, yeah, so where are we? What's going on? I'm back. All right, so we've created the part in library.io. So that's now associated with my account, my library.io account, which means I can't really like share it with anybody. I don't know. I think I can do stuff to export it and share it, but it's part of my own library, and I think they disabled like the public sharing or whatever. Like I think there are some companies that share stuff, but it's so weird. Like I don't know why I would have to replicate the job of somebody else, but I guess in this case, like trusted parts are a big deal in creating a circuit board, because you don't know what somebody else is doing. You don't, like the shenanigans that we went through in order to create this thing. Like, maybe you don't want that. Maybe you don't want somebody to have fiddled with the numbers until this came up like this. Maybe you want your pads to be big square pads that sit underneath these. That kind of stuff you don't know if you're getting when you get somebody else's external part. So the important thing that I'm trying to relay to you is known, trusted parts are worth their weight in myrrh. They're very, very important. Known, good, trusted parts that you've done designs with, which is another thing that leads into my complaints about the library manager in Eagle, is that, you know, I need better accessibility to the notes. I need better accessibility to moving parts around easily. I'm sure that stuff exists, and they go, oh, all you have to do is click in here and hit this combination of buttons, and then this combination of buttons, and then Control-C-V, blah, 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 blah. No, it just needs to be universally simpler, because I need to be able to say, oh, I'm done with this board. These are good parts. These all worked out. Oh, this resistor was a little tight. Let me leave a note for the next time I get to it. I can't do that as easily with Eagle. They'll get there, hopefully. I have hopes that they'll get there, because they have been working on every other facet of the software. So maybe they'll pull in a consultant and go, how do you do this? And the consultant will be like, what the fuck am I looking at? Maybe they'll, because they seem kind of ingrained in the way that things should operate in Eagle. And I would like them to break out of that and become more like Fusion 360, which has this beautifully intuitive flow of processes to go into anything. Anyway, I'm just old man yells at cloud. All right, so we've got our part. It's 1.2 millimeter by 1.2 millimeter. The layout kind of sucks. The pads are kind of weird. I think we can try it, and I think I'll probably be able to solder to it. I hope. It's an oddball, but I think we'll probably be able to use it. I just don't like, you know, like, where do I put the signal coming out of this thing? Very strange. Okay, so let's finish that. Version of your package will be created, after which you can generate new packages starting from this package's parameters. Cool. Okay. So all that layout stuff, all that copper layer, the pads, the keep out area on top of the pads, the pin assignments, et cetera, et cetera, et cetera. All that stuff is, you know, ones and zeros. It's all going into the software right now. And we are creating a new version of this package. And then all I need to do is assign pin to pin to pin to pin, and then I can start using it, and we'll do that. So there she is. There's my package. Got a version history. We got the thing there. It named it. It named it QFN65PL120 blah, 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 blah. I would love to rename it, but I don't know if I can. Yeah, this is annoying. So yeah, I guess I can give it tags if I really wanted to, but IPC standard name? I don't know. 4-pin QFN-FT. I'm not going to bother with all this stuff. Yeah, I don't know how this stuff works. So I think we're just done. I think we're done with library IO, because now we need to go in here and we need to find my own QFN that I just created. If this undoes it and it doesn't actually exist in this list, there it is. Okay, so that's the one. Name of the new package variant. Q4 QFN-FT or something. I don't think that's standard, but I'm just going to do that. That's got to download it, of course. All right, there we go. And it looks like a little stress thing in anime. All right. And there's our package. Look at them go. So it has just added this thing. It's got all the layers of the board all ready to go. Everything's laid out, all perfect, wonderful, amazing. It doesn't know what pin is what. I've given it a schematic symbol with 4 pins, but it doesn't know what pin goes where. Ugh. I need to get a haircut, guys. I'm sick of looking at this. I don't like this.
Need to get that trimmed. We're getting in dangerously mullety territory here. So yeah, connect. That's our next thing. Connect. And now I've got 8 pins. I don't know where they are. Hold on. Before we do that, I'm going to take a look at the footprint and figure out what pin is where. Because I don't know which ones, in standard QFN parlance, which ones go where. Pin 1 and 8 is pin 1. 7 and 6 is pin 2. So 8, 7, 6, 5, 4, 3, 2, 1. That's how it goes. It goes in counterclockwise. Well, it goes in, yeah, anti-clockwise from pin 1 on the left. So 1, 2. So in this case, pin, oh God, all right, pin 1, I can't believe this thing worked. You know, after all that soldering that I just did, how this thing just worked in the circuit, given that I'm so confused about what pins are where. 1, 2, 4, 3. So anti-clockwise. So 1, 2. Well, pin 1 is pin 1. Pin 2 is pin 2. Pin 3 is pin 2. Okay, so let's roll with that and see if I can get these assigned properly. Connect. So pin 1. Well, pin 1 isn't ground. Oh, Lord. Okay, all right. Ground is on... oh, my God. All right. We're getting into 3 references deep here. 3 references deep. Because the numbers aren't the numbers. 1 is VDD. Here we go. That's what I need. All right, so VDD is pin 1 and 2. VDD, pin 1, and pin 2. No, pin 1 and pin 8. Because remember, we're going around and it loops. 2 and 3 are pin 2. All right. Connect. Ground, which is pin 2. Double check that, make sure. So we can do this now. We can struggle with this now. We can spend the time to bend our brains around backwards, to squeeze them out like a paper towel in order to get all of our brain meat out and make sure that our beef brains are able to actually put all of the pin assignments to all the pin assignments so that in the future we can be beef brain and we can just do whatever and get it all together without having to think about it too hard. That's the wonderful part about schematic tools, about CAD tools, is that they're going to give us what are called air wires, and all we need to do is look, air wire go there, air wire go there. I draw a squiggly line, and then it's fine. So that's the beautiful part about what we're doing right now, and that's why I'm stressing about getting all the pins. That's why we're 6 data sheets deep in numbers and connections and stuff like that in order to get this right, so we don't have to think about it in the future. So yeah, it would almost, I don't know, I'm almost considering like whether or not I want to do like a custom, do more of a custom pad for this. I don't know if like calling it a clock would be a better idea, because the clocks have those corner pads. This has corner pads, but it wants weird. We'll leave it the way it is. All right, so pin 1 and 8, the first and last pins are in that upper corner. Next corner, 2 and 3. I want to try conductive 3D printing. What I really want to do is what Applied Science did. The problem is, what I want to do is too complicated. The project that I would have in mind for that kind of thing, too complicated. For conductive 3D printing, Applied Science is able to etch traces onto 3-dimensionally printed objects. I don't think he used printing itself. What I would love to do is that game Ruiner from a long time ago. It was a little top-down, sort of very twitchy, too fast for me game. I loved the game. It was too fast for me. But Ruiner was really cool because the main character was in sweatpants and a motorcycle jacket, and he had, because this is a whole like cyberpunk like body modification thing, so he had kind of a helmet that was close fitting to the face, but the whole thing was an LED array screen that was pretty dense. And I'm like, there are addressable LEDs. I wonder if you could make a mask like that and have all the LED structure. And the thing is, like, curved featured LED screens are tough. You need like fiber optics to do something like that. Or I was thinking, you know, have your structure and then solder the LEDs to that by making it into a circuit board. I don't know if that would be, I don't know if that's tenable. I don't know if that's something that could be done. I guess you can make it in fiberglass. That would probably be better, but that's not, I don't know. Anyway, I haven't messed around with conductive 3D printing. Anyway, ground. Ground is pin 2 and 3. Connect. In. I gotta make sure to get this one right too. So 2, 3, 4, and 5 are gonna be in. And then 6 and 7 are out. That was a weird part. That was a weird part. We got it all in there though. Everything is up to date. Everything is connected. I'm gonna Control S this mofo. And then we will be able to add it to the device. Look at how easy that was. So it was so easy. So easy. Step 12B, subsection A. God. We got it done though. It wasn't terrible. It wasn't good, but it wasn't terrible. So let's put the part in here. Not in here. Let's put the part, we'll see it in there eventually. Oh dear God. So we got a couple revisions going into the schematic. First of all, dead. Second of all, dead. All you dead. Let's see. That resistor, dead. Yeah, basically blowing away everything. Everything's gone. We got a big design change here, folks. This is a big design change. Everything's changing. Times are changing, old man. And with it, the FETs. Okay. Don't need you. No more diodes, no more excess parts. Look at that. Beautiful. All right, so what we need to do is I need to duplicate these parts, and then we need to add our parts into it. So let's get rid of these traces. I'm gonna have to keep these organized, aren't I? I don't remember what goes where. Oh no. I've got kind of a general idea. Well, we've got the software open. That'll tell me what pin goes to where, right? Oh boy. It's all gone to crap. There's no going back. Oh my God. So many revisions. Here, I'm gonna move those LEDs a little closer because we need room in the schematic for stuff. So do those there, that there. All right, cool. Got separation of our stuff. Now let's add. Well, I mean, I guess I could just put them in as, so the parts that I put in, the other ones, the MOSFETs, I did the same process too, including adding a schematic symbol for them. The problem is I had to go into that symbol and I had to edit the pad because the pad split up that big drain pin. And the big drain pin is super important because that's responsible for bleeding off all of that excess heat. So you want all that metal. I think I know where my other ones went. I think I have 2 of the end channels on the old controller board, and I'll have to take them off of that because I want to be economical about this until I know when the back order is in. I don't know where, you know, who makes these? Vishay. I think Vishay has been hit by silicon shortages as well too. But yeah, these were like hot shit on the market apparently. I don't know. I don't have any external sources of that. It's not like there was a news article about companies buying these things, but I mean, they sold out of them and now I can't find them. So I've got them on back order. So anyway, we're gonna go to components because a FET is a component in my mind. End channel, and then I've got it right here. So you got 2 different packages here. One of them is just the regular old SOT 23 version, which is a nice compact little guy. The other one is the super duper ultra fancy boutique, hard to find, super duper one. The SIA. I kept the -N on there. I should have put a space in there, but it's the SIA 400. So let's add that. A different version is present in the file, needs updated. Yeah, update everybody. And then this apparently can just go like that, which seems very wrong. Now, I can twist it with the right click, but I need to mirror it. So center click, and it just pops it over and it mirrors it. There we go. That's those two. Next, I need to add my own little guy here. And I put this in as a chip. I don't know if that's in the wrong category, but whatever. So this would be the Mike 5019 blah, 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 blah. I took the longest title I could and put it in there. So let's put that one in there, and we're going to need the software to catch up with me. We're going to need 4 of these. Oh, dear God. Okay, and then, I don't know why it keeps the $sign on that. I would rather it just say U11. Why does it have to do that? Oh, and it also, that horizontally mirrored it. Okay, Control Z these. Hold on. Z, 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 Z. So why are the $signs visible in this? Is it because of what I did? No. Oh, why did that change to G $1? Because I just put name on there. I just said name. It shouldn't be a $sign. That's so strange. I don't know how to correct that. That should be U something or other. Wait, this should be correctly oriented, right? Yeah, in and then out. But yeah, they're calling themselves U's, but they're putting that big $sign in there, which is not what I want. All right, so highlight that. Let's get that sort of in position. That's going to need to connect to all of those, and then I'm also going to need 4 caps. This is, in terms of drawing a schematic, this is where things are going to get a little bit crazy. Things are going to get a little bit crazy. I'm going to try to fit it onto this page, but I'm going to need 4 capacitors in here, and we'll probably need these grounds. So pull that over here, and then we don't need that there. I'll tighten this up a little bit. I don't think I'm going to need any of this room here, but I'll just tighten that up for me. That's for me. Do we keep the Schottky diode? I don't think we need the Schottky diode. It didn't seem like we needed it in the other board. Maybe I can keep it and not populate it, because the Schottky diode is there specifically to isolate the motor and the capacitor. Basically, the motor is on the other side of that cap. I don't have it schematically represented here. That would maybe be like a footnote or something. Yeah, Demi, everybody's been having problems with Twitch today. Twitch has been a buffer monster. I don't know what they're doing. They're probably going to update something so that we have more, I don't know, annoying something. You know how Twitch does? They do be like that. But yeah, we've had a lot of complaints about people having player problems today. I don't know what Twitch is doing, but it's not me. It's Twitch, and it's not you. Twitch. All right, capacitors. We need some caps in here. The caps that I used are 4.7 microfarad. They are what size? That is a weird size. No, these are a choking hazard. I probably shouldn't have messed with these. X5R? What the hell is X5R? So do I have any 3-dimensional X5R capacitors? As he says it, the spinning wheel of doom ticks a couple times. Get out of here, Twitch. Stop screwing up my... What the fuck is this? We got some corrections to do here. Why do they look like that? Well, I guess the numbers that I put in I can get rid of. So yeah, let's go back to that schematic symbol. Symbols, Mike 5019. Double click it. All right, so I can get rid of this, I guess. The problem is it's representing both of the numbers on these, and I don't want it to do that, but that's just to get it onto the footprint. Code Rush, raiding with a party of 22 people. There's no expression change in my face at all. I'm just doing this to seem like it's hype. Okay, anyway. Now that everybody's sick and buffering, How's everybody doing? Twitch is having a lot of problems today. Everybody's buffering. If you guys are buffering, reload, I guess. I don't know. Welcome to the shop, Code Rushed. You guys are familiar with me. You know what I'm about. You know what I do here. You know what we're up to typically on days like this. I'm working on that RC car circuit because I have an addiction. It's an affliction. A restriction of friction. I don't like that. Anyway, yeah, I'm like addicted to RC cars now. I'm doing my own little like boutique. You know us. We create circuit boards here that do all kinds of weird shit. I'm creating my own like boutique exploration of N-channel FETs. N-channel FETs. Chat's fathead. No, it's my fathead that's on all the bandwidth right now. N-channel FETs and creating parts in Fusion 360. Yes, indeed. I have these FETs, these N-channel 30-volt DS power trench FET, MOSFET, whatevers. What these are designed to do is be part of an H-bridge motor circuit. And this H-bridge motor circuit is designed to power my RC car. My RC car is using one battery cell, so 3.7-ish volts, one battery cell. Why the restriction? Well, because these little cars are actually pretty fast for what they are. I don't need it to be ultra, super, mega, ridiculously powerful. Now, in the future, perhaps I will be tempted to go to a 3-phase motor because they've got better motor control. But for right now, what I'm trying to do is design an H-bridge motor controller that's going to control this 130-sized Tamiya DC motor. It's got big windings in it, and it's really powerful. And so if I can use these motors, I've got a variety of different motors that I can actually swap in to have fun with and try to, mess around and see what works. Check it out, mess around, see what's going on. So that's what I want to do with this. Now, I have kind of gotten carried away because I'm trying to put all of the electronics, the receiver, an actual gyroscope so that it can do steering corrections, a receiver, a gyroscope, and the main motor controller all on one board. DOS Micro is a company that makes a lot of these very, very, very tiny little motor controller stuff, little RC stuff. This is an 8-channel radio, and it's about as big as a literal thumbnail. It is literally as big as my thumbnail. So I want to use all that stuff, and so I decided that I could put all of that stuff onto one big circuit board, and I did. But the problem is I didn't vet out the MOSFETs very well. The DOS Micro motor controller also used different switching FETs, MOSFETs, in order to turn the motor on and off. I ended up burning up the MOSFETs. They didn't quite work, and they didn't work at the lower voltage. I took some out of the wltoys kit, which is what this is, WL989, and then I've made a lot of modifications to it. So I took the FETs from the WL989 controller, and I hooked them up to the DOS Micro controller, and they worked great. They were a little large, though, and so I decided to put everything onto one circuit board. And in doing so, I found these absolutely minuscule MOSFETs, but they didn't quite work right. So today, we installed these MOSFET drivers. Dun, dun, dun. They're even freaking smaller. Good Lord. Look at the size. Look at them. But they work great. They work perfectly. They just need one big capacitor, and the motor driver. And then you just hook the ins and the outs together. You don't even need to invert the signals now, and those will drive the N-channel MOSFETs and get that motor basically churning around. That's where the motor should go. So that was a rousing success. We had that was a great result. Like immediately, everything worked great. So yeah, those people who are still watching are actually survivors, because Twitch is being an absolute shithead right now to a lot of people. I apologize. I don't know what to do about that. I can't do anything about Twitch. I have a goddamn mullet. I'm gonna get I need to schedule a haircut tomorrow. Maybe I'll just walk in to the haircut place tomorrow. They cut hair like it's 1970 there, though. That's why I look like this right now. Anyway, sorry. I should go to a modern place and get the sides of my head shaved, and then have long hair on top. Would that work? No, I'd look terrible. I'm not muscular enough for that. All right. Anyway, so yeah, these FETs, they're really cool. They work really well. They don't even get hot. They get warm during operation, but they can handle a shitload of current. Those were easy enough to get into CAD. These guys are what we just got into CAD. This is 1.2 millimeter by 1.2 millimeter. It just has 4 little pads on it. But in their data sheet, they had all these weird ideas of what you should connect where. And so right now, I am just refining the schematic symbol that goes in. So I'm going to hit save on that. The pinout is going to be ridiculous. It's going to look like crap, just because that's just the way it is. Oh yeah, and here's the model for the whole thing. So here's the space that I'm trying to fit the electronics into. Very restricted. Very restricted. But it should work. That clipping is concerning me. I can move that up later once I get more of an idea of how this thing is going to go together. Yeah, so that's what I'm trying to fit it into. And so in order to do that, we had to make the new part. And the new part, we put it into the board. Okay, come on. Where's my schematic? We're just refining the schematic at the moment. Here, I'm actually going to get rid of those and put them back in. No, get rid of the whole thing. So, chips managed. This guy. And I got 4 of these going in. 1, 2, 3, 4. I need to fix that naming convention. Unfortunately, it's all terrible. I don't know what's going on with that. Just being here is low quality. Hey. Lower stream quality helps. Yeah. I don't know what Twitch is doing right now. I hope, have they tweeted anything about like what's going on? So this part is wonderful. It does not need a whole lot of excess stuff for it to function. So we're making a little bit of room in it for the schematic. I need to have a 4.7 capacitor in here. So let's get that in here. So chips manage components cap. So these are defined 0402, 0603, 0805, 1206. I want to say 0805 is probably the size of this. This says it's X5R. So let's do a little bit of work before we commit to the part. So capacitor, I'd spell that really wrong. Capacitor size X5R. I could probably use a chart. Oh, Jesus Christ. It's statistical probability. Images. I want capacitance. I want the... Huh, maybe that's not the size. No, 0402. Okay, so X5R is a material. That's not the... Oh, these all say 0805 on the package. All right, so we'll do 0805. I've tested 12 streams, no issue. Then I return here and it happens again. Is something wrong with New York? Blah, 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 blah. Looks fine. German, New York. The hell? Yeah, I don't know. There's nothing, must be somewhere else. Okay, so we got those parts in. We're doing 0805. And so those will go between VDD and ground, which is going to get real awkward around here. I guess I'm going to have to just drop them down like this. Here, why don't I just cut and paste the whole structure? That's probably a little easier. Just get rid of the excess here. Put it all back down. 0805, put that in there, and then we'll get the 5019, put that down. What I want to do is I want to take this to the point where you guys get to see this in the three-dimensional design. So we'll do that real quick. ISP backbone, yeah, maybe. So yeah, we're going to need 2 ground symbols on this thing just because of the way it's laid out. That's fine. I'll just cut and paste the ones that I already have. So I can just do... Huh, weird. Okay. Yeah, CV. Okay, copy paste, I guess works that way. All right, so just line that up like that, and then I need 2 ground symbols. Put one there. Just get the other one nearby. Move this one way over here. So that one's going to go with that. Even the text of the part is getting in the way. Ugh. So the standard, like the way that I do stuff, I don't know. This is just so much different. Because basically what we're doing right now, Isaac Ewing, thank you for following. What we're doing right now is we are programming a computer. This is not so much. It's better to not think about this like it is an actual professional schematic, because this is not. If I were to make a schematic to share with other people, I would not be using this software to do it. I think Eagle schematics are particularly hideous looking, and they've got kind of that. They all stink of it. They all have this kind of like hideousness to them that I don't like. That's just me. I like to have, slightly different, everything to be a little bit cleaner on it, which is why I use MS Paint a lot to do schematics. But what we're doing right now is we are programming. I did that completely stupid and wrong. What we're doing is we are programming this software to know what traces connect to what traces. This is not creating a schematic symbol for another engineer. Although I do follow the conventions for that, it just helps to think about it that way. All right, so escape from that, and now I need 4 of those. Four of them, and they're going to take up a crap load of space. So paste. Let's put. Well, can we fit 4? We're not going to fit 4 like that. I'm going to have to stagger them. Let's take these and we'll move them out and up. Hopefully not grabbing that with it. Good. All right, so we'll do it like that. That's just going to get. It's going to get real sloppy. Yeah, Q1, what are you doing, buddy? Going back to where you came from, buddy. There we go. All right, all right. Oh, he's off grid. He's off grid. Oh, my God. All right, we'll just leave him right there. All right, then one more, and that one's just going to sneak in over here. These are basically just in and out, so. All right. Oh, God, this is a mess. All right, let's get this thing connected. That one to there. This one to here. That one to there. And this one all the way over here. Oh, yeah, in terms of updates, by the way, guys, Octojay got the tablets back, and he says they're fine. So. Paint is indeed the best drawing program out there. You are correct, Groovy. Sergeant Pyro Man, Twitch is all fucky right now. Twitch is all messed up. Twitch is... Bleh. We don't know what's wrong with it. Yeah, I know. Everyone is having problems with Twitch today, unfortunately. All right, now what's my motivation? I need to figure out what lines go where. I don't remember. So I think the best thing to do is... The reason that I program stuff the way that I do, I always do the pinouts and stuff up at the top of the drawing like this. And here's the reason why, is when we are sitting here authoring a circuit board and everything goes psycho on us and we don't know what's connected where, I come back to these notes at the top of the document. Boom, there's my pinout. I know what's connected where. So, pin 2, Q1, forward. Pin 2, Q1, forward. That's this one. What is our bias in the forward direction? I'm going to go with these, well, my Q1, 2, 3s, and 4s have moved. Now, in terms of the way that I'm thinking about it, we're going to call this one Q1, Q2, Q3, Q4. So Q1 and Q4 are forwards. So then that goes here. And that's going to do this end channel MOSFET. Now, if I were, I could move stuff around a little bit so I don't have that little jaunty little piece right there, but that's okay. I'm not going to stress about that. I can actually tighten this up a little bit. I'll do it one block off from connecting there, and it doesn't help a ton, but it does help it a little to look a little better. Okay, so Q1, and then this one is the counterpoint to that. Oops. So break LED user input. Q1 forward. Q2 is on the reverse LED. That would be, and that's pin 3. Pin 3, John83, thank you for following. Pin 3, this one is reverse, so this one goes to the opposite side, high side. So the high sides turn on and off. The low sides pulse. So there's that one. This is going to get a little convoluted, isn't it? Yeah, the high sides turn on and off, which is why they're also connected to the LEDs. In the previous circuit, in order to run P-channel MOSFETs, you had to connect them to ground. So the positive on signal that would light up the LED would need to be inverted. We did that with a transistor. We don't need that now because this chip is just off and on. It's doing an N channel and it's positively biased. So yeah, that's easy to do. And we don't have pull downs on these either, although we might need them. We might need to add pull downs to these. Gannett Dak, thank you for following. So we might need to do pull downs on these. I'm not totally certain about that. Hey brother, how you doing? Okay, so now I gotta be careful. So pin 6 goes to Q4, which is forwards, which means this one is forwards, then this one is forwards. So that goes all the way down here. So this is coming all the way down to here. Oops, that's a little, well, I can correct that. I can correct that. I can move that up there. Ta-da! Okay, so there's that. And then now by default, it's just got to go. This one's got to go here. Done and done. These chips are helping clean up my design a little bit. A little bit. Okay, so now we have, as I said before, we've now programmed this thing to have all the pins in place. Now, I didn't do pull-down resistors on this. So the default state of these might not be where I need them to be. Although I might not need pull downs on them. If they all, like the second this thing comes to life, they should all be pulled down by the Arduino. But if the Arduino takes a little bit of time to get there and it leaves one of them as a float state, I think that chip might handle it for me. So yeah, I think this is all we need. This is all we need. We've got our forward indicator, our reverse indicator. We've got our user indicator. We have all of these hooked up to their N-channel driver chips that are designed to punch up the voltage a little bit so that we can make sure that our MOSFETs are definitely getting switched. And then we've got all N channels here configured in exactly the way we had them on the breadboard. So this is an RC car circuit. So now we can go to the two-dimensional PCB design, which is the big button in the corner, the big magical button in the corner. What that's going to do is it'll place all of my stuff over here, kind of far away from each other. But we do have all of the stuff. God, that is such an awkward... See, this is what I'm talking about. Wait, how come that one has a conflict on it? And this one doesn't. Oh, maybe because it's V plus and ground. That's not good. But those should be 7, 6, 5, and 4. What? 2? Wait, 1, 2, 4, 2, 6, 2, 2, 2. What the hell is this? Okay, something's messed up. This is why we do this. Yeah, so I wanted to take you guys all the way to having the 3D thing here. How far from finished product? I don't know, man. I do not know. This is a labor of love. What we're trying to do is fit the circuit board into a tiny little RC car. It's a 1/28th scale wltoys 989 chassis that I reverse engineered and put into Fusion 360 so that I could pull parts from GrabCAD and other sources like that and author basically a circuit board that's going to house everything, all of the electronics, but under the outside of the body so that I can put another body on top of this thing. I'm going to try to 3D print some kind of a fancy sports car body. But right now we're dealing with the reverse engineering and recreation of the main board, which is also responsible for being the motor controller. It's going to control the H-bridge motor controller. And so there's, I don't know, there's something funky with this part. Something funky with this part. Let's open up the whole device. Okay. That little info thing, I wish I could disable. 1 and 8, 6 and 7, 4 and 5, 2 and 3. That should be fine. So why is it so confused? Why does it have 1 star 2 on it as the name? Hold on a minute. What's going on here? Let's like disconnect all of them and see what happens. Yeah, that goes away. Okay, connect. So VDD technically should be that pin right there. G1 VDD. That's pins 1 and 8 according to how they're numbered. Ground is pin 2 and 3. In 2, 3. Let's well, I can't double check. 4 and 5. And then 6 and 7 for out. But then I've got star 2 on that. What does that mean? They're technically the same pin. It's just the way the software put them together when we auto-generated the package. Now I guess what I could do is I could define a new footprint, and I could go in and actually like create, using pads, I could create a 4-pad, footprint for this thing that I could solder it to. That would be easy enough to do. And then we would just have to place that 3-dimensional part on top of it. Just a little odd to me that everything kind of broke. Oh God, all these toolbar items that you have to click this thing in order to do this and that and the other thing. I don't even know what I'm doing right now, CAD. You're not the boss of me. I don't know where I am right now. A wild card. Yeah, these were properly connected, I guess. I mean, they seem to have signals on them. It's just I would have to ignore the design rule error that's going to pull up, because those two are too close to one another. I guess the ×2 just means that it's 2 pins in 1 or something like that. That's my best guess. Everybody else who's watching just sees buffering. Also, why are those pads so long? They seem like really, really long pads. Anyway, so I can rearrange these things so that they're in logical locations on the board itself. So for right now, just for the sake of argument, I'm just going to put these into sort of spots on the board so that you guys can see them actually propagate into the 3-dimensional design. Oh, that one switched sides. So center click will switch sides, and then it'll invert everything for you and all that. And right now, I'm not really concerned about the names of stuff, like the symbol names and stuff, because that's just going to be all over the place no matter what. The last thing that I typically do with a design is I'll go through and I'll unify the font size and all that stuff. Then again, the more parts that I get from library.io, the more consistent those will be. But I don't understand why all of the referential stuff broke. Like $10, it should just be U10. And it shouldn't even be U10. I need to get like a renumbering utility going on this thing, because there aren't. And you got Q1 through 4. This should be a U. I don't know if the other stuff counts as a U. Hey, where'd that go? I got rid of my trace. Yeah, so we got a bunch of capacitors and a bunch of other stuff that's got to go in here. Lord knows where I put them. Let's see. Now, I mean, I could probably put these close by, but I do want room for all the traces in there. This is going to take some soul searching for me to figure out what goes where on this. I mean, I don't think I can put the high side drivers all the way over here and still get them all the way up to where they need to go. I could maybe flip the script on this thing a little bit. Of course, the top of the board, on top of the, like under these modules, I got tons of space there, but I'm not using it. Let me just get them on the board and you guys can see it go into the three-dimensional design, because I think that's the more impressive facet of the software for now. Guess I can go under here. It's hard to sort of like actualize what's on top of the board, what's under the board. You kind of got to get used to looking at it in a certain way. Oh, and none of my design rules are in here. Yeah, it's letting me get too close to the edge of the board. Okay. Seed Studio has a file that you can load that gives you all of the different like spacings and stuff like that for the various like tolerances that they will make a board under. So how close can components get to the edge is one of the major factors, or how close can traces get to one another, things like that. That's why I was so annoyed when I saw the little like, hey, you can't do this outline around part of these pins, because these pins should all be connected to one another and they should be okay with colliding. Otherwise, it's going to throw a design rule. So let's say I put all these things down and I did all the considerations that I typically do in a board, right? Make sure that the traces are large enough that they can handle the amount of current. Make sure there's vias everywhere and all the ground planes and stuff like that. And I have everything in a position that I want it to be in, and everybody's getting fed enough current, et cetera, et cetera, et cetera, right? Everything is in place, and now what I can do is switch to the three-dimensional design. And what that's going to do is it's going to pull from the library all of those 3D designs, the pad layouts, the thickness of the traces, things like that, the board coloring and stuff like that from that two-dimensional file. And then it's going to freeze, which has not happened before. So that's cool. Awesome. La la la. We apologize for the inconvenience. An error report has been generated. Software fusion unexpectedly. Okay. Provide step-by-step description of what you're doing. This time I was streaming to like 80 people and it crashed. Never had this happen before. Just doing 3D, doing library.io to schematic to schematic to 2D board to 3D board, 3D borked. Twitch TV, oh bother. Send report. I don't know what happened. I was just clicking stuff. Thank you for your error report. Well, I might have lost a little bit of work there. Now everything along the line saved. I'm hoping the schematic saved at least. The layout stuff I'll have to figure out. And then the question is it gonna crash again when I try to make the three-dimensional board? But since it's like 5, that's about closing time. Not really. It's a little early. Again, I'm sorry about these early streams. We had a rousing success with using that part. We just weren't able to get the full 3D render experience. But you could see kind of how it propagates through everything, right? Yeah, I'll go through the auto recovery in a minute. It's gonna dox my email again if I'm not careful, so I'm just gonna do that off air. But yeah, you can see the process here, and the added parts of the process for what I was working on today is that once I get that 3D render, if I save that, because I've pulled that 3D render into an assembly in another file, that file will update, and then I will need to go to the main assembly of the RC car, and it'll pull up a little dialog box that says, hey, some of these parts have been updated. You go, okay, update them. And so you tell the software to update it, everything will come through, and then you'll get your full design that you've just altered propagating throughout the entire thing. So if you're trying out a new part that might not mechanically fit, you can put it in the schematic, pull it through the rest of the process, position it correctly and everything before you commit to where all the traces go, and then see how it mechanically adds up in your Fusion 360 drawing in the end. It's been a very powerful set of tools for me to be able to put together these little RC car boards. I can't sell any of this, by the way. I can't, because it's an educational copy. I'm not going to be taking this one to the to the old Tindy or whatever. I don't have a Tindy store. But, you know, hey, maybe I can do a kit at some point if people are interested in this. I don't think they will be, because I'm dealing with like H-bridge motor controllers and not putting full power through this thing and all that stuff. But you know, I've had fun with it. Anyway, yeah, I guess that's where I'm gonna leave off for today, because that's a stopping point. Kind of sucks though. Kind of sucks. I gotta make sure I save stuff, and then I gotta go through all the auto recovery steps or everything. But this is an idea of how sort of the whole design starts to come together, right? Everything starts to come together at this point. I've made revisions to my design. I've vetted out the parts. I've explored the errors that I've gotten in previous things. I've got the software running 100%. Almost like 99% of my parts have been selected. Now I need to go through those bits of the process, refine everything, order circuit boards, get those in, 3D print parts. Everything's going to start rolling, and I think the RC car stuff's going to come together really well. It was the answer to this whole thing was just this N-channel FET driver. That really helped. I mean, it wasn't even, I don't know. Part of the problem was that my bench power supply wasn't providing us with that quick kick of current. So if I stall the motor and try to accelerate, the FETs close the circuit on what is not a very big coil. All of that current rushes into the motor, and then the voltage drops, and then the radio resets. But that's because my power supply did not have a reserve of current that it could suddenly punch out before it was able to cater to that. I'm a little worried about that. Maybe that's the cheapness of the Chinese power supply unit. Maybe that's where we're running into that. Perhaps I could put a big capacitor somewhere in there, but I'm not going to do that for right now. But yeah, once we hooked it up to the battery, we were still getting noise. We hooked it up to the battery. That seemed to solve it, at least in this instance, depending on where I plug it into the perforated prototyping board. And then we weren't getting full throttle. Our full throttle seemed like not that good. Turns out we needed N-channel FET drivers. So that allows me to use one single kind of FET. I can just use the N-channel FET for the whole thing, and I get that little bump in voltage that's going to pop off those FETs. So now I got better control of the FETs. We've got more current flowing through the whole design. Things seem a little bit more spry. They seem a little bit more agile in my mind. I mean, I'm just listening to the motor, but I think we're in good shape. So I'm gonna follow through on this, get the design done, get it all in 3D and stuff, and then yeah, and I'll have our RC car. Let me move on to other stuff. Thursday, we're gonna be working on the computer. I need to work on the computer. I need to get this big NXZT case and all of its accoutrements, all the stuff in there. I need to put it into the rack, and it'll look cool, and it'll have a little bit of water in it. It's just generic water. It's not even cooling water. I'm just going to sneeze on it a lot. It'll have water, and it'll have a cool looking front face and all that stuff. It'll be great, and then people will like us, and they'll actually start talking to us again, finally, because you know, we can't keep living our lives like this. anyway, we're gonna get that computer in there. So that is Thursday. We're gonna work on that stuff. That should be pretty straightforward at this point. I've got too many parts, and we've got all the stuff printed out for it. The only reason I've been putting it off is because the past couple weeks have been shit-shaped to stream on Thursdays. That's not gonna happen this week. I'll be ready to go. So I'll see you guys then. I don't know if there's anyone that we can particularly raid. Not to mention the fact that Twitch is just being an absolute crazy person today. I mean, the usual suspects are on. We got role playing and all kinds of other stuff going. Oh my God, it's doing it to me. It's doing the loading thing to me. Okay, we're gonna bury the stream in the backyard. All right, nobody's gonna ever know about it. We'll never talk about it again. Twitch is just being psycho. Let's just old yeller this shit, and then we'll see you on Thursday. All right, have a good one out there, everybody.